the Earth's surface. No.
That's not what I'm. Did you hear what I said, dude? I said the space in between is expanding in all directions.
No, it's not.
Okay, bro.
Yeah, that's okay. So real quick,
how do we have denser objects at the surface?
There's this thing called the Hubble constant. Okay, it's meant to model the expansion rate of the universe. And when you say the universe is expanding, most people think of that in terms of like, okay, the space. Like we've got this thing called outer space, and like bodies float around in it like a giant swimming pool, an empty swimming pool, right? This empty swimming pool is growing. That's how people think of it. But what Lanolin is saying is it's not just that the empty swimming pool is growing. Every single object in the swimming pool is uniformly growing as well. But it's actually not perfectly uniform. There's like some asymmetries in the rate at which some stuff grows compared to other stuff. So they have to apply essentially hot fixes along the way, which have become dark matter and dark energy, which now it's gotten to the point where it's like 95% of the universe.
It's true. It's true because it's coined as the fine-tuning argument. That's what's known as the
but we don't talk about that on the surface of the Earth, though. We don't talk about expansion of the universe on the surface of the Earth. It doesn't. Like,
that's why we talk about. But the reason it matters is because if you only focus on the surface of the Earth, you could talk about Newton. But then when you do Michelson Morley, they had to get rid of Newton, had to go to Einstein. But then if you're going to say it's Einstein, then you're no longer concerned with just Earth. You have to consider the whole universe.
Oh, I don't have to go to Einstein with Michelson Morley at all.
Hey guys, this room's getting too crowded for me, so I'm gonna move to a different one because it's just too much. I'm gonna move somewhere else.
He needs to talk. You
can't have it both ways.
Yeah. Nobody thinks that the Earth is actually expanding.
But the universe is expanding, though. That would include everything within the universe.
Well, that's why I didn't disagree with anything he was saying. I was just saying when they say they treat something as such, they're not saying it's actually happening one way or the other. It's just from this reference frame, from this philosophy. This is how we're treating it.
No, it's from all reference frames. It's from all reference frames. They claim the universal expansion would look the same no matter where you are. It's isotropic, in the same in all directions.
Yeah, you guys want to pretend like you want to hold on. You want to pretend like it's neutral. They don't actually make any positive claims. You want to enjoy the benefits of two mutually exclusive options, right? And be like, we don't believe in absolute motion. We don't believe in an absolute reference frame.
That's not what I said at all.
No, but that's exactly what you're saying, and then you're asserting, no, that's not what I said.
No, I'm giving you my understanding of treating a calculation as something.
For you before you get to this thing.
Okay, we got too many talking. I wanted to make a point, just a quick point. When you're in a car and you accelerate, it pushes you back in the seat, right? So your car's accelerating forward, but it pushes you backward, right? When you're standing on the Earth, you're measuring a weight that's pulling you down to the surface, and that's a measurement of acceleration upward. So if that's what they're talking about, the Earth expanding, but it's not actually expanding. That's just the force that's measured at the surface.
Well, it's not a force that's measured. It's an acceleration. F equals ma. Gravity's
force. Yes, that's what it is. Weight is a force.
Yeah, so weight would be the acceleration times the mass, but see, the acceleration is the constant, not the force.
It's a force.
No, the force is variable.
Y'all are getting it all mixed up, man. It's so mixed up, I don't even know what to say, man.
Objects of all weights experience the same acceleration. They fall at the same speed. Doesn't matter if it's a bowling ball or a mountain. They will fall at the same speed.
Correct.
So,
and that's where relativity kicks in because you don't feel a force when you're falling.
When you're in free fall, free fall is very, so we can explicitly measure forces acting on bodies that are in the state of free fall, and bodies in free fall are defined as having no forces on them. That's the definition of free fall.
That's why physics says that we're accelerating upward, but not in actuality, like we're not actually moving.
Dude, you'll hear them say that the Earth is actually accelerating upwards.
Well, there's different schools of thought between many scientists.
Who says the Earth is moving upward except for people of the flat Earth who think that might count for gravity?
Yes, I promise you, Globers have said it.
Go ahead,
all the time.
Only when you're talking about an apple falling off the tree, and from the apple's frame of reference, it does appear that it's just hanging out in free space while the Earth is moving up.
But we know it's not getting bigger because the radius is the same. Like, that's not this hard.
If you were free falling in an infinitely large vacuum chamber, would you continue to accelerate and then notice the change?
No.
You wouldn't be accelerating. Falling is a constant velocity, no acceleration.
How have we confirmed that? What's the longest that we've been able to capture free fall in a vacuum?
Let's see.
In vacuum, you don't feel. Yeah, in a vacuum, you don't feel any force. So when you're falling, you're not experiencing any force.
Oh no, I agree with that. I'm just saying, while it's falling, when the object is falling in a vacuum, Is it accelerating as it falls?
Toward the ground? Yeah, if you use that, but actually it's the ground accelerating up toward the object in relativity.
Oh yeah. But essentially, I'm saying so the object like a sun or the Earth free falling in a vacuum, it's going to continue to accelerate.
No, that's something
No,
different.
not
That's orbiting.
What's it falling?
Not necessarily.
Yeah. It's not falling.
Why not?
Falling means you're going toward an object usually. So when you use the word falling, it doesn't really make sense with the sun or the Earth.
He's confusing this with the explanation of orbits as falling, but going sideways enough that you don't hit the Earth.
I mean,
well, is it really sideways?
A curve.
Oh, go ahead.
Yes. In order to go to orbit, you need a shitload of sideways, which is why they generally launch eastward from as far south as they can.
But he's right that a circle in an orbit, they're just following a straight line. Like you wouldn't know you're accelerating inward and with gravity because of mass bending space-time.
So is your universe that you believe a fabric of space-time?
That's the terminology we use to make it simpler for everybody to understand, but it's not actually like a woven fabric like you think. I assume you're thinking.
No, not like a woven fabric, but like a surface area. Similar, because when you build a gravity well, let's say the sun is creating a gravity well in the fabric of space-time.
The thing about this is this fabric of space-time. This fabric of space-time is an analogy to explain a two-dimensional surface stretching into the third dimension, just as the three-dimensional universe stretches into the fourth dimensional time. That's more difficult for people to understand, so they try to get the analogy of the two-dimensional surface stretching into the third dimension.
Do you think that's happening with the sun on a physical?
Yes, they've shown that. Eddington showed that at the eclipse that light bends and as the sun bends space-time.
Yep.
So space is being bent and time, right?
Space-time, one concept. Four dimensions, space-time.
Yep, it's not. You can't do them individually.
Yeah. So do you believe the sun is actually warping space and time? Space-time.
Time.
Space-time. Yes.
Space-time, yes. It's been proven.
Eddington showed that. Considered one of the evidence for relativity.
Einstein. I was nobody really before he came along.
So is the gravity well also falling?
There's no such thing as falling in space.
Or is the gravity well? I guess the gravity well, in your opinion, is moving along with the sun.
I would say that time doesn't exist outside of that quote unquote boundary. Is it a hard boundary? We could never go there. So it's kind of like saying what's outside of reality.
Yeah, I posted a video from PBS Spacetime. It's an old one, but a goodie. It's Gravity and Illusion. And it said it's the same exact thing that the other dude was saying, Lanolin, like verbatim. It's funny. It almost makes me think that he watched the same video. But I have a guy in here from Reddit who has a good analogy. He says, maybe the following can be a good analogy to grasp this theory, because people are questioning how can everything be expanding outwards in all directions, but yet the Earth maintains its structure. And he says, imagine you are floating in a lake and your position is steady. Now imagine you are floating in a river, and if you do not look at the bank, only the other floating objects you may think it's still a lake. There's no reference point from which you knew you are actually going down by the river, but suddenly there's a vertical grid firmly installed at the bottom of the river, which does not let you go further. Only the water. So the water is moving, but you yourself aren't moving. You're fixed to the grid. However, you may still think you are in a lake. And someone moves a vertical grid horizontally on the bottom of the lake. The water is analogous to the space-time, which flows outwards from the center of the Earth in all directions. And the grid is the Earth, which stands still firmly in the flow of the space-time. So compared to the space-time, the Earth is accelerating upwards, but rather the space-time flows towards the center, and the Earth is just a filter, which does not let you flow further by the space. I think he says something wrong right there, but
that's pretty good. The bending of space-time makes straight paths curve. Veritasium has a really good program about this and makes it sound a lot similar. But if you were in space and you were coming from another galaxy toward Earth, let's say, and you were going straight, you would eventually curve into Earth, but you would never feel it because space-time bends. So you don't ever accelerate when you quote unquote turn toward the Earth. It's just bending the straight path as a curved line.
No, I know.
Crazy.
It's called a geodesic. But the space-time itself is moving. Like the space around you is moving, is expanding, and there also seems to be a flow.
Yeah, I mean we're getting.
I don't agree with it, but
that's fine. It's hard to grasp.
But Einstein literally, like, the Earth is actually accelerating upwards. It says proper
Yes,
acceleration, but it's because of space-time.
Yep, exactly. So it's not actually moving. It's the space-time around it is being warped, which gives the effect of you accelerating upward.
Well, we don't know.
We don't know what.
They don't really know what's going. There's no absolute frame of reference. There's no preferred reference frame. There's no absolute motion. There's no absolute space. There's no absolute time in Einstein's relativity. So you can't make a positive claim.
But we know we're not. We know we're not accelerating outward on the Earth because the Earth is
how do you know that
shape.
How do you know that?
Because the radius of the Earth remains the same.
Yeah, but according to them, according to the equivalence principle, you can have two inertial objects accelerating due to space-time, and you can't tell what's actually going on.
You can't tell which one's moving. I agree with that, but you can tell acceleration for sure.
There's coordinate acceleration, there's proper acceleration. Like you could literally have two inertial objects falling to the ground, even though they're falling and moving, and you physically see it moving towards the ground. It's in an inertial state because you're not actually picking up proper acceleration. Instead, the Earth is accelerating upwards, even though those objects you see them moving towards the Earth, right? They say that those objects aren't actually moving, that the Earth is moving up. It's space-time that's causing you to perceive that. It's an illusory perception. The objects are actually falling towards the Earth.
And all reference frame. Go ahead.
No, I was just saying it's reference frame dependent to describe that motion.
Yep.
Yeah, but there's no preferred reference frame, is what I'm trying to say. So either observation is valid.
Unless you're going toward light speed, in all reference frames, the Earth is still the same shape.
Even with a third person perspective, like if you were able to see the entirety of the Earth and see two objects accelerating towards the Earth, antipodal to each other, right, in this hypothetical, you would think that that would give you the definitive preferred reference frame to know what's going on. But they still say nah, like there's no preferred reference frame.
Yeah, I agree with that. But in any of those reference frames, no matter where you are around the Earth, it's still a sphere of the same radius.
Yeah, I know. We bring that up, dude. We bring it up all the time to the people that say that the Earth is accelerating upwards in all directions.
We can actually say that because we feel it in our feet every day.
Yeah, it's called weight.
Yep.
Little g.
Yep.
We can measure the kinetic force of objects hitting the ground from different heights, and they hit the ground with greater intensity or kinetic energy the higher that you drop the object. So you can objectively see like what's actually going on, but they, for whatever reason, they want to deny natural phenomena or natural observations in preference of this theoretical mathematical model. We can see the downward acceleration. We can see the kinetic energy multiplied. F equals ma. We can see it multiply.
Why is it multiplying?
Because the higher that you drop it from, the greater it accelerates downwards.
No, it's accelerating. It's accelerating the same speed or same rate the whole time. It's always 9.8 meters per second.
You're not listening, dude. Yes.
You said they accelerate differently. They don't.
Yes, from different heights. There's a variable acceleration. Yes, I get it that the gravitational constant is 9.8 meters per second squared. But what I'm talking about, you can drop objects from different heights at the same time, and they'll hit the ground. The object dropped from the greater height will hit the ground with greater kinetic energy, showing that what's actually going on is that the objects are actually falling to the ground, even if accelerometers don't pick up the acceleration. It's not because
how do you know
the Earth? It's not because the Earth is accelerating upwards. It's because the accelerometer is limited in its engineering, so it won't pick up acceleration.
No, we know we're accelerating upward. There's no doubt about that. Because
how do you know that?
When you're falling, you weigh nothing.
Yeah, because you're weightless, dummy.
Yes, because there's no force. Yes, we agree.
No, because you haven't reached equilibrium yet. You have to actually be on the surface to weigh yourself, dude. Why would you expect it to have any weight when you're still falling in the air, dude?
Equilibrium.
You are not experiencing you're in equilibrium when you're free falling.
Yeah, you have to reach equilibrium. That's why weightlessness.
Free falling is equilibrium.
It's actually
free falling is equilibrium.
It's actually
No,
not. That's
it
why.
100% is.
That's why you're
No.
accelerating until you actually reach equilibrium, which is actually known. You guys have inverted Newtonian mechanics, right? So in Newtonian, inertia means what? At rest, right? What's the inertial reference frame?
No, inertia means constant velocity.
What I'm trying to tell you is that the Earth is actually the inertial reference frame. It's not moving. It's stationary. It's stable. It's fixed, right? That's the inertial reference frame. You guys have inverted it. You're saying that the Earth is the non-inertial reference frame because it's rotating and the objects falling to it are in free fall. Even though they're falling, even though they're accelerating towards the ground, you're expecting me to believe that that's the inertial reference frame because it's weightless and you can't pick up acceleration because accelerometers are limited in their engineering.
It has nothing to do with accelerometers.
Accelerometers measure acceleration.
There is no preferred reference frame. On Earth, we are accelerating upward because force equals ma. We wouldn't have weight.
It's begging the question. It's begging the question, dude.
No,
I get it that you can pick up. I know, dude. I get it that you have a weight on the Earth. How is you having a weight on the Earth means that the Earth is accelerating upwards, dude?
Because force equals ma.
That's begging the question.
No, it's not. We are accelerating.
Is.
Otherwise, why is it so hard to stand up and walk around?
That you're begging the question, dude. Just because you pick up, just because you weigh, right? Just because you have weight doesn't mean that the Earth is accelerating upwards, bro.
Yes, it does. It literally does.
How?
Force equals mass times acceleration. Weight is force.
Bro, stop giving me a convention. Explain it.
Yes, we feel acceleration moving upward. Just the same way somebody just described it. When you accelerate in a car, if you were blindfolded, how would you know you're accelerating?
Yeah, I get that. That's what accelerometers.
Answer the question. How do you know you're accelerating?
Because G forces.
Where do you feel it? In your back, right?
It depends on which direction. Yeah, but it depends which direction. Yeah.
Okay.
If you're going around a bend, if you're going around a bend, it's going to be have centrifugal forces.
But if you were just driving along, you wouldn't feel that acceleration anywhere as you go forward because you're not accelerating. But we feel it in our feet here on the Earth when we're standing up, or we feel it on our back when we're laying down. We are accelerating upward.
Yeah, I understand that you think that weight equals that the Earth is accelerating upwards. Yeah, I know that. That's what I'm trying to hash out right now. That's what I'm trying to flesh out. And you think that because when you drive in a car and you experience G forces, and G forces can be multiplied, like if you're in a jet, the faster that you move, the more that you'll weigh temporarily. It's not that your mass is changing. It's not that your mass is changing. It's just that you're accelerating, causing your weight to increase, which is what they transfer into G forces.
It has nothing to do with the speed. It has everything to do with acceleration. It's not speed. It has nothing to do with speed. If you were going
I didn't say speed. I said acceleration.
Yes, you did. You said faster.
Yeah, the more that you accelerate, the faster that you accelerate, the more that you'll weigh, the more the G forces are applied on your body.
That's why on the moon we would weigh less.
Okay, so what's your point? You're saying that because when you drive around and you experience G forces, therefore the Earth must also be driving around?
So yeah, what do we feel on Earth? What's our G force on Earth normally when we're walking around?
1G.
Yep. What is it when we're falling? What G force are we experiencing when we fall?
Is weightlessness equals 0 Gs?
Correct. So you just proved that we are accelerating upward because we feel 1G when we're standing on the Earth.
That's not a proof of anything. You're jumping to conclusions, dude.
Okay.
Because accelerometers are limited in their engineering. They can't pick up.
That's not true.
It has nothing to do with accelerometers.
Yes, it is true. Yes, it is true. Accelerometers can't pick up G forces on a downward vector unless there's thrust applied.
Yeah, that's why there's no force. That's because they're not measuring the force because there's not a force when you're in free fall. Accelerometers do exactly what they're supposed to do.
No, we can pick up the force. There's multiple ways that you can pick up the force, and you can measure it. When that object hits the ground, the force is multiplied kinetically. We know it's moving. We actually know it's moving, and we know that because how do you explain forces being multiplied at different rates from different heights?
Because the Earth is accelerating.
It's increased its velocity.
I understand that you think the Earth is accelerating, but if Earth is accelerating at an equal rate in all directions, why is it that when you drop objects from different heights, it hits the ground with different kinetic force?
Because
it's increasing its velocity.
Yep.
No, but if what you're saying is true, right? All those objects should hit the ground with the same amount of force, regardless of altitude.
No. That's not
right. Yes. And then there's other ways you can use optics. You can use optics like interferometry. You can use lasers. You can use radar guns, and you can measure the acceleration, the proper acceleration of these objects. And not only that, you can actually do some, forensic evidence, and you can see the impact craters, bro. You can see it for yourself.
That's because the velocity increases as it falls. That's why it hits the ground harder.
Yeah, proper acceleration. Thank you.
No, light actually bends downward on the surface of Earth because it's accelerating upward. This is a testable thing that they've done. So just like on a rocket ship, if you were to accelerate upwards, the light, if you've shown a light straight across your rocket ship as you're accelerating upward, where you shine it from to where it hits the wall, it will go down as accelerating. If you're going in a stable motion or just at stable velocity, it will not. It will travel straight across with no bending. On Earth, when we do that same test, the light bends down toward Earth, showing that we are accelerating upward. That's another test.
If you don't believe what I'm saying, Bacon, who's a staunch Glober proponent, he actually agrees with me on this.
I doubt it.
I'll tag him right now. Bro, because he understands that accelerometers are limited in their engineering. They can't pick up downward acceleration. You understand that?
Because there is no downward acceleration unless you throw it down.
Like, how do you know there's no downward acceleration? How do you know that?
Because standing still, we feel an upward acceleration.
That doesn't. How does that justify your premise that there's no downward acceleration when I already gave you multiple avenues that you can use to see downward acceleration? You can set up a camera and you can drop an object with a meter stick on the side and you can see it accelerate. You can use interferometry, you can use radar guns. You can literally put a laser on the fallen object with a reflector on the ground or vice versa, and you can pick up acceleration, downward acceleration, proper acceleration.
How do you know it's not upward? You're doing a preferential frame of
reference. You can use optics, you can use lasers, you can use light, you can use cameras.
How do you know what's accelerating?
If you're not persuaded by any of those options, you can literally measure the kinetic force that's multiplied by measuring the impact of these objects.
How do you know which one? How do you know?
All these. Dude, I'm providing evidence for my premise. All these examples will show you that there's actual acceleration going on, even though you guys want to keep pointing to the accelerometers.
How do you know which surface is accelerating?
The objects falling to the ground are obviously accelerating because when you drop them from different, when you drop, it doesn't matter. It's not reference dependent. You can literally put an object measuring the difference between the ground moving up and the object falling to the ground, and you can measure the acceleration of the object towards the ground. And if that's not persuasive enough, you can actually measure the craters, dude, and the impact.
You're so wrong.
What about men on the other side of the world? Are they accelerating up while the other side of the people on the other side of the world are accelerating up?
Yep.
Not necessarily, not in their model. It is accelerating upwards in all directions, but not it's due to space time. But what I'm trying to say is that you can act like Newton. Newton was actually sensible. Newton believed in absolute time. Newton believed in absolute space. Newton believed in absolute motion. Einstein doesn't. But you can actually objectively you can show these guys, right? But they're not persuaded by all the examples I'm giving them. You can literally put a reflector. You can literally put a reflector on the ground, and you can put a laser on the fallen object, and you can measure the differential between the laser that's being propagated hitting the reflector as the object falls to the ground. You can have multiple objects drop from different altitudes, and you can measure that differential, and you can see that there's proper acceleration going on there.
Which surface is accelerating, the object or the surface of Earth?
Obviously it's the object, dude. Why would you think it's the Earth?
How?
Because because the kinetic weight is multiplied depending on the altitude, dude.
If the surface was moving
up, if it was the Earth moving up, like you're saying, you would expect all the objects to equal the same amount of kinetic weight.
Wrong. That's wrong.
No. Yes.
It's wrong.
Why?
That's completely wrong.
Why?
Because it doesn't matter which you're doing. You're doing what you started talking about, preferential frame of reference. That's what you're doing now. You're literally doing
there is a preferred reference frame. There is an absolute reference frame. The Earth is not moving. The Earth is fixed, stationary, and immovable, dude. As many times as you want to say no, you're wrong. I'm providing examples where you can go test this for yourself. Einstein wanted you to deny your natural observations and believe in this theoretical model. That's the difference. You can actually test this for yourself. You can set up. Hold on. If you don't like the interferometry, dude, you can set up a radar gun. And you can set it up on the fallen object. You can set it up on the fallen object, or vice versa, and you can see what's actually going on.
Okay, if you had two planes accelerating toward each other, how would you know which one is accelerating faster in space? If you were in the airplane, how would you know which one's accelerating faster?
The same way that all the different scenarios that I just laid out. You can use the lasers. You can use a radar gun, just like a cop on the highway, dude. When he shoots a radar gun at a car, he knows how fast that car is moving towards him, dude. The same thing.
No.
Yes.
He could be moving at the same speed toward that car parked and get the same answer.
Nope.
Yep, 100%.
That's wrong. Nope.
Oh my gosh.
You can no, because you're talking about there's a difference between relative motion. Yeah, there's a difference between relative motion and relativity. Relative motion is not mutually exclusive to the Glob model to relativity. Newton believed in relative motion. Newton believed in relative motion, and yet he also believed in absolute space and absolute motion. Einstein didn't. Yes, because you're making baseless assumptions, baseless claims without backing them up.
You think a radar gun that is moving in a car will be able to tell if that car is moving or if the other car is moving toward it? You think that?
Yes.
Oh my gosh, I can't help you. Okay, so all I would ask you is why do we have? Do you agree that force equals mass times acceleration or not?
No, hold on. You need to back up your claim.
No, ask me.
Don't run, dude. Back up your claims with evidence. Back up your claims with evidence.
Yeah, here we go. Do you believe that force equals mass times acceleration?
Yes.
Okay, why do we have weight here on the Earth?
That's the crux of the conversation. That's the age-old question.
No, yeah, why? How would you explain it?
I'm not sure. I'm not exactly sure what causes weight.
That's fine. The model shows that we're accelerating upward. That's why we feel weight here on Earth. So
but just understand this.
Hold on. If you get a better explanation than that, bring it forward. But until you do, that's what we're left with at this point.
What?
We're accelerating upward because force equals mass times acceleration. So we have to be accelerating upward.
No, we don't, bro. Why would weight equal the Earth accelerating upwards? That makes no sense, dude. That's logically irrelevant, dude. Just because there's weight on the Earth doesn't mean that the Earth is moving upwards, bro. Come on.
Yes, 100%.
No, it doesn't.
Where does acceleration come from? Why F equals ma?
That's the age-old question, bro. That's the age-old question. But why would I think that the Earth is moving upwards in all directions, or accelerating upwards in all directions?
We didn't say it's accelerating in all directions. Where I'm standing, it's accelerating upward. We can prove that because force equals mass times acceleration. Until you figure out a different reason where that acceleration is coming from, that Einstein is shown to be correct.
Nah, dude.
That's a nuh-uh. Until you have a different explanation of why we're accelerating.
Bro. You're the one begging the question, bro. I'm being honest. I don't know what's causing weight on the Earth.
I do.
No, you don't. No, you don't.
Force equals mass times acceleration.
I explained it to you. Go ahead, Nasa. You're up.
Force equals mass times acceleration. Why is that difficult to understand?
Yeah, what you call acceleration is a little g, dude. It's just weight.
Yeah, okay.
It's weight.
Weight is mass times gravity. Yeah. F equals ma. Weight equals mg. Yeah, we got it.
Yeah, you're begging the question.
Acceleration.
You think because
no, we're not begging the question.
Yes, you are.
No.
I posted an image of the globe with two directional arrows. Can you guys? Oh, okay. So Wesley, can you explain how it's moving in both directions simultaneously?
It's not moving. It's accelerating because of the bending of space-time.
Okay, can you explain that in a little bit more detail?
You apparently not.
It's a straight line around masses are curved. It's a very difficult concept, and I would just tell you to watch Veritasium on how gravity works. It's done very well. NASA still has it right there.
So we should just take that as a no. You can't explain it.
Not to you.
Yeah,
no.
Not to you guys. Rigger, you're so far.
You just don't understand it.
Okay, Rigger,
let's give it a try.
Insult me because you can't understand something. You can't answer a question. Don't say.
Yeah, we're asking you.
I just
do understand it. We do understand it. We've been trying to explain it.
Okay, then explain it, please.
We have.
Can you explain it, please?
Yeah, sure. We have acceleration here on Earth. It's provable because we have weight. Force equals mass times acceleration, and so we're accelerating. We also can prove it because mass bends and warps space-time. This was proven by the Eddington experiment. Stars appeared where they shouldn't have, and that was proof of the sun warping space-time because they were shown in different spaces, and it was predicted before it even happened.
That's not an experiment. Also, what are you talking about?
Also, yes, it is. And then we also sent atomic clocks in airplanes, and we showed that the warping of time slowing down in that.
You're so dude. All of that's begging the question. Textbook begging the question.
No, wait a minute. Hold on. Stop. That's not begging the question. That is having a hypothesis, then going out and measuring the data. That's not. It's not.
Yeah, but that's just an observation. Okay, you haven't actually manipulated the independent variable. You haven't verified or isolated the cause. You're saying, you're saying this must be time dilation without actually being able to manipulate time. This is time dilation.
They calculated the amount of time dilation that they should get, then they measured it, and they were well within the error margins.
Yeah, but that's not mutually exclusive to Einstein's relativity or time dilation. There's other factors that could lead to the same conclusion, dude.
Like what?
There's a tons of so when it comes to the cesium atoms, their oscillations. There's a host of factors that could cause the cesium.
Very precise.
So the cesium atoms oscillate at different rates.
By the way, they also left one at home, not moving, and then they compared it. And when they compared it, originally they were.
And they had to constantly calibrate them
Nope.
And they have to, yes, dude, they have to keep it in a certain calibration as they go up. So that means they're actually.
It's not a fake
no,
thing.
dude, you have
It's
no
not
idea
a
what
fake
you're talking
measurement.
about.
You have no. I know you have to say no.
There are other things that can affect the oscillation of the cesium atom. We know that electromagnetic forces can affect it, and the voltage potential. The voltage potential as you go up can affect the cesium atom, leading you to believe in time dilation.
Incorrect.
Make a prediction.
Everything you just said.
We're talking about we're talking about picoseconds here because there's a change in picoseconds. Therefore, time dilation is true. You guys are ridiculous.
So send up a helicopter. Send up a helicopter and see if the same thing happens. Then, Lion.
Okay, but before we get too far into the weeds, let's talk about this acceleration. So you guys believe in this idea. So is in this acceleration upwards on both directions, is it moving? Yes or no?
No.
So Earth is not moving?
Well, Earth is moving, but not outwards in all
The
directions.
radius is constant. Yeah, the radius is constant.
Yeah, yes, we know that, but the Earth is physically moving.
Yep.
In free space, right?
Yep.
Because it's also accelerating upwards, right?
No.
Is it accelerating while it's moving?
You feel acceleration. You feel acceleration upwards. It's gravity. That it's actually bending the space time, but that's okay.
Okay, so perfect. Last question. So while the Earth is moving around its orbit, when you're on the North Pole and you're at the South Pole, it's both accelerating in both directions?
That's what you feel.
For some odd reason, though, you weigh more at the poles than you do at the equator. Well, that can be measured too. That's interesting.
And just because we don't know the cause doesn't mean that it equals relativity. You understand that?
Actually, it does, but that's okay. The fact that you have to say no,
the fact that you have to say no,
the fact you have to no so hard and so furiously without any other data to replace it says a lot about you.
No, bro, it's an argument from ignorance because
no,
just because we haven't,
right. You're arguing from ignorance.
Yeah, you're right.
Just
you are
because
ignorant.
dude, can I talk? Just because we haven't isolated the cause and verified the cause with a proper experiment, manipulating an independent variable, and I'm humble enough to concede that I don't know the cause of gravity, doesn't mean that it automatically means relativity is true. That's textbook argument from ignorance. We don't know why X happens, therefore Y must be the case.
You are arguing from ignorance. You are arguing from ignorance. You have to say no because gravity is real. We know it's real. We've measured it. The fact that time dilates has also been proven. The fact that you don't like this is another issue.
You don't know the cause, bro. You've never isolated the cause.
We do know the cause.
Yes, we do.
We do know the cause because the one where they set the airplane on the airplanes going opposite directions, they calculated according to the theory how much time they should change, and they were well within the errors for doing that. That's called a hypothesis, and going out and getting the data and showing the hypothesis to be true.
All you have is a hypothesis. You never
actually we went out and got the data that supports the hypothesis.
Nope, dude. Whether it's Foucault's pendulum, whether it's the laser gyros, whether it's a cesium atom, all these things are not mutually exclusive, nor are they proper experiments.
Please tell me.
You can't manipulate independent variable.
Oh my God!
No,
isn't an answer.
Any of these experiments, they're not mutually exclusive.
You're ignorant.
Relativity.
You're ignorant.
This is honest truth, guys. This is honest truth. They want to laugh and mock and scoff.
You're ignorant. Your ignorance is not my problem.
And he won't stop talking.
None of these are actually proper. My God! How about you? You're the one who's been blabbing for the last 5 minutes.
They're only observations. They're only observations.
No, they're not.
They're not. They're experiments.
What's wrong with the experiment in a plane? Hold on. What's wrong with the experiment in a plane?
What do you mean? It's not an experiment. That's what's wrong.
It is.
Why?
It is an experiment.
No, it's not. It's an observation.
Why is it not an experiment?
It's all you have is an observation and some data gathering. That's it.
No.
You're collecting data.
They sent in opposite directions. They predicted what they would see and think. They manipulated the variable.
Yeah, that's fine.
They manipulated the variable by speeding it up, by going faster.
There's nothing wrong, dude. You can come up with kinematics all day long and predictions
based off of which.
Hold on, bro. The motions. You can predict motion.
Well, fine. Then explain it. I want to see. Show me the math.
It's motions without force.
Show me the math.
Without. Bro, just hold on, bro. Just give me a second.
Show me the math. No, you can say this all you want. I mean, you can blah 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 all you want.
Until
you have the math that shows it. No, listen. You can blah 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 all you want. All you're doing is blah blah blahing right now. You're moving your mouth, making noises.
What are you doing, NASA?
What I'm doing is I'm trying to get
in a conversation and not letting the other person talk.
No, wait a minute, hold on. He's had the floor for most of the time here.
Yeah.
You just got here. All three of you came in together, and you just got here. It started with Wesley came in, and then his butt buddy and you showed up, and you're just trying to chop line the whole time he's talking.
The problem line is he won't shut the fuck up. He says something, and then he goes on about it.
I just looked up kinematics, and this is what it says, and it's exactly what I said. Kinematics is a subfield of physics and classical mechanics that describes the motion of points and objects and systems of bodies without considering the forces that cause them to move. So what did I say? I said it's the motion without the force.
Show me the math now. Good. Now you have a hypothesis now. Excellent. Well, this is a great experiment. You got a good one now. Now you've made a hypothesis. It's due to kinematics. Now it's up to you. Excuse me. Listen. You have a hypothesis. It's due to kinematics. Now it's up to you to make a forecast using kinematics and how that would work, and then go out and redo the experiment and see if your hypothesis is true. My guess is you won't be able to do that.
Right. You can do that with kinematics. That's what the ancients did. That's what the ancients did with habitual observations. You can make predictions, pragmatic predictions about the luminaries, about the motion of the
We're not talking about the luminaries. We're talking about atomic clocks.
The sun rising in the east, right?
We're not talking about the sun rising in the east. We're talking about
hold
atomic
on,
clocks.
dude. Yo, why is he doing this? Yo, you can make kinematic predictions regarding all types of shit without actually ever having to get into the dynamics, which explains the forces at play. So when it comes to the cesium atom and its oscillation rate, or when it comes to gravity and all these things, you can make predictions about gravity. You can make predictions about cesium atoms, but you've never isolated the dynamics, the cause, which is the crux of the conversation.
You have a good hypothesis.
You can make habitual observations and predictions, bro. They did it with epicycles.
Excuse me, you have an excellent hypothesis. You have an excellent hypothesis. Yeah, he's talking about anything except atomic clocks. So you have an excellent hypothesis. You say it's due to you say it's due to kinematics. So now my thing is, okay, you made a hypothesis. Now go out and do the data and figure out how it's going to work kinematically to explain why time dilates.
All right, are you done? Because when I talk,
are you going to do it? Are you going to do the data? Or are you going to flap your mouth?
So just because I don't know again, just because I don't know X doesn't mean that therefore Y is true. You understand that? So just because I can't provide, hold on, bro. He's doing it again.
God, you're coming out with
just because I can't provide,
and then you just flap your mouth.
Dude, you need to shut up, bro.
You come up with an hypothesis, and then you do nothing but flap your mouth.
Just because I'm
not humble, you're dumb.
And I say that I don't
over everybody now, sir.
Gosh,
want to do that?
No, wait, hold on. All he's doing is diverting away from the question.
Is there any mod here?
So now you got to talk over me. So now you got to talk over me now, right? You got to talk over me now. You got to talk over me now, right? You got to talk over me now. Yeah, you got to talk over me now, right? So talk over me now. Yeah, go ahead, talk over me.
Right?
Yeah, his problem is the lion here is talking out his ass.
You have nothing to contribute.
Okay, I'm going to turn.
You dodge everything that's proposed to you, right? And then you just spiral into some ad hoc nonsense.
So again,
while you taught people,
you made a hypothesis now. Now it's up to you. Now it's up to you to come up with the data to support the hypothesis.
I can match you all day, bro. You're boring.
Meta rigor.
Yeah, that's what it's been for the last 10 minutes, bro.
Come on, Lion. You made a hypothesis. Now can you go out and get the data? Until then, you just have an unproven hypothesis.
So what we do know about cesium atoms is that there's multiple things that can affect the oscillation rate of the cesium atom.
Like what?
Dude, shut the fuck up.
Like what?
Shut the fuck up, dude. He's asking me a question. I'm answering him, dude.
No,
okay.
Like what?
Like what? Yes, I am. I'm answering him. So there's different forces. There's different forces, including electromagnetic forces and electrostatic forces, right, that affect the oscillation rate of a cesium atom. You understand that there's a voltage potential as you move up in the atmosphere. You understand that? It's about 100 volts per meter. You guys can see that. So
it doesn't affect me.
So there's other forces. Hold on, dude. There's other forces that can affect the oscillation rate of the cesium atom. Just such as other forces that can affect the precession of the focused pendulum. There's other forces that can affect the gyros. All these things, right, are not mutually exclusive to relativity or time dilation or the Glob model.
Excuse me, the pendulum and the gyroscope have nothing to do with time dilation. You can forget that. That was just you making shit up.
Hey, and also, Lion, if you think it's electrostatics, then fly a helicopter up in the air and see if it changes the time on the clocks like it did when they were moving. So go ahead and do that.
Are you kidding? Dude, this guy for real right now? Are you trolling right now, dude?
That's what you said. You said cesium is affected by the electrostatics, and you said 100 volts per meter would affect it. So go fly a helicopter straight up instead of the... that's control.
Yeah, that's what I'm trying to tell you. Yes, I do expect to see a very nominal change, right? When we're talking about cesium atoms, we're talking about atomic... Hold on, dude. I'm still talking, fuckface. When I'm talking about cesium... Dude, yeah, because you guys keep interrupting me. When we're talking about atomic clocks and the cesium oscillation, we're talking about a very nominal deviation from the surface of the Earth, right? We're talking about we're talking about picoseconds here, dude. Picoseconds, bro. Very, very minute change. So I do expect to see a change. Why? Because you have various forces that are changing as you go up, like the 100 volts per meter.
Okay, demonstrate it.
Wait, hold on a second. We can control for that because we can send a helicopter up and see how much it changes. But then we can fly a plane and it changes a lot more the faster we go. So we can control for other variables, and that's what science does. So the fact that you're not the first one to think of other forces.
It's inconclusive, dude. It's inconclusive because it's not mutually exclusive to the globe. So none of these observations are mutually exclusive to the globe. You know this. And until you're
saying it without any evidence.
This is not because I'm not denying that focused pendulum moves around, dude. I'm not denying that you actually experience some type of difference in oscillation of the cesium atom. What I'm denying is, or even with the Cavendish experiment, the mass attract the mass, I can concede that these balls are moving towards each other. That's not mutually exclusive to relativity. Do you understand that?
So prove what other variable it is then.
So I can grant you that the atomic clocks are changing as you move up in altitude. But how are you so confident that that's due to the bending and warping of space-time?
Because we've controlled for every other variable, and we've tested it many, many times in many, many different ways. All you have to do, Lion, is to figure out what the other variable is, test for it, and show that you're... Hey, stop interrupting. You don't like to hear that? No, hold on a second. You don't like to hear it because that's all you have to do. But none of you guys are scientists. And so you're not going to do it.
So have you controlled for gravity?
For what?
Or a clock? How do you know that you don't have
controlled for gravity?
Oh, good point.
For what?
Can you control gravity? Can you manipulate it?
Yes.
No, you can't.
Yes, I can.
That's the honest truth. No, you can't. And until you can manipulate gravity successfully,
no, the question is,
you have not isolated the cause.
How? That's a nuh-uh. All you have to say how. You said nuh-uh. Say how. How can we control for it?
You can't.
I don't know how to control for it. If I could control gravity, I could isolate the cause.
You can control for gravity. You want to know how?
All right, let me ask. Yeah, let me ask Wesley. Wesley, how?
You're going to say distance or time, which is a different variable than gravity. Okay,
no,
so that's not your independent variable. You don't know what an independent variable is, right? And you're just going to infer from other information. You're going to say, I have this independent variable, and from this, I'm going to infer what gravity is and
what is gravity? Pure gravity. Pure rigor? What is gravity?
You don't know. That's for certain. You don't know because you think you can manipulate it.
Okay, yes, I do.
So there's no way to explain something like that to you when you literally think you can manipulate gravity.
Okay. You can manipulate its effects.
You guys don't like the word gravity, and I understand why. So we'll call it giggity.
Nobody dislikes it. It's you claiming, making a claim you can manipulate something nobody can.
Gravity is not a variable. Gravity is not a variable. What is the variable in gravity?
Okay,
is the
now it's not a variable.
Hold on a second. Stop interrupting. The two.
Oh, you don't like it? You don't like it, Wesley?
Yeah.
I can't talk to you, but you can talk to everybody.
Go look in the mirror. Go look in the mirror. Okay. The two.
Hey, I was saying quiet, so you guys came to creating chaos on the show combo. It was going pretty good until you asked
Just be quiet, bro.
Oh, you don't like it? I'm just calling it how it is. You see how I'm derailing you right now?
Rigor, man, why don't you shut up, man?
Oh, it's okay for them to come in and do this, but I can't do it back to them? Why is that a problem?
Because you only talk meta. You have no content. So the reason is that what gravity is
the guy who claims you can manipulate gravity.
Yes, I'm going to tell you how you can. Gravity is the attraction between two masses. So what you do is you change either of the masses and you change the distance. Those are the independent variables of gravity.
So you change everything except for gravity.
Nope, that is changing gravity. You're too dumb to realize that.
No, bro, you're trying to isolate. No, we're talking about cause and effect relationship, dude.
Yes.
You understand that?
Gravity is the attraction between two masses. You think you have to actually manipulate, like gravity is an independent.
That's science 101, dude. What are you talking about?
No. Okay. So Lion, in electromagnetism, I'm assuming you agree with that because you keep talking about electricity. How do you manipulate electromagnetism by itself? Go ahead, Lion.
There's plenty of ways, bro.
Ahead,
you got Van de Graaff generators. You got different magnets, electric magnet. You got electric magnets that you can literally turn on and off. You can literally manipulate it. You can turn it on and turn it off. But do you have an anti-gravity machine? Do you have an anti-gravity machine that you can turn on and off?
Slow down.
Well, I already answered your question, bro. Answer my question.
No, what's the variable you're manipulating? You're not manipulating electromagnetism.
Yes, I am. There's electromagnets at the junkyard, bro. They use them all the time, dude. What are you talking about? Do you have an anti-gravity machine, though? Do you have an anti-gravity machine, though?
What variable are you manipulating?
The gravity, dude, do you have an anti-gravity machine? Yes or no? I already told you the independent variable is the one that you manipulate. So if in my experiment, if I set up an experiment with an electromagnet, the independent variable would be the electromagnet.
He's so dumb.
I mean, this is real simple, though. It's real simple, though. If you wanted to measure the forces between the two masses, you measure it with exercise masses. Then you get a bigger mass. You're going to measure a greater force. If you move them closer together, you're going to get a greater force. You're manipulating the effect of gravity.
Yes.
No, that's not cause and effect relationships, dude. You're not isolating the cause.
Not understanding. You think in electromagnetism, all you're doing is you're changing the charges. You're not changing electromagnetism. Electromagnetism is the force between two charged particles. You don't understand this. That's why you don't
actually. He's so silly. You don't actually have to go to the quantum scale, bro. Come on, bro.
No, you changed.
If that was the case, then you could not. Yeah, you would have no experiments if that was the case, dude.
Okay, what's the variable for electromagnetism? What is it? What's the variable?
Potential would be one of them.
What are you talking about? You want me to come up with an experiment?
No, not electromagnetism. Okay, great.
Do you want me to come up with an experiment like right now, dude, in the cuff? Like, what do you want from me, dude?
Yeah, what are you changing when you're testing electromagnetism?
If you want to test for the cause of electromagnetism, you have to be able to manipulate it.
How do you manipulate electromagnetism? What are the units?
With electricity.
What do you mean?
Electromagnetism. It's in the word, dude. Use your brain.
You can't. Oh my god. So what is the units of electromagnetism?
Why are you just hurling out fucking questions?
You're just scattergunning at this point, bro. Will you go back to the conversation at hand? Can you manipulate gravity? Yes or no? Because we can manipulate electromagnetism all day long, dude.
Can you manipulate gravity?
Yes. We can. Yep, we can.
Manipulate gravity. Yep.
All right, so do this, right? Simulate your model in a room. Yeah. So do this. Simulate your model in a room. Go ahead, do it, because you can manipulate
You
gravity. You can control.
Now he wants a mini physics.
If that's
he wants
true,
a mini globe and mini physics.
If it's true that we can sit here and manipulate gravity, all right, so therefore we could create our own planetary bodies in orbit and demonstrate that in real time.
Can you show us
because now we control gravity. It's not a fact that we can't control, right? We have like complete influence over it. Okay, so do it.
Cavendish,
so do it.
You got it.
Cavendish didn't do that.
Yes, they did.
I'll drop a link for you.
You think one word answers the question? No, Cavendish literally did not do that. You can't control gravity. This is pure disruption. From the original topic, that was going so good.
Easy. Pure rigor. Your mind is so simple.
All right, let's see that demonstration.
By moving the big map, he manipulated gravity.
Yeah, let's see the demonstration.
Sure.
There it is, right there.
Blue did it. Blue built a 2/3 scale of the original.
Yeah, let's see it. Let's see it. I don't want to talk about it. I just want to see it.
You see that big button? It looks like a play button. Press that. Watch it for a while.
Can you?
No, he probably has me muted. Or he's just ignoring me.
I mean, y'all just deny it and wiggle around, but you have to better with magnetism.
You guys are mixing. You guys are mixing causal science when it comes to like a hypothesis, right? And descriptive or relational science, where you're trying to establish a property of an object. In this specific case, you're not trying to establish a property where you can move. You can just move the objects around, or you can change yourself as the observer. You can move the observer around. That's descriptive science, right? We're talking about causal and we're talking about cause and effect relationships.
Yeah. In Cavendish's experiment, he moved the masses and the weights responded.
Yeah, that would be descriptive.
Yeah, he was not. No, he was manipulating the
descriptive science. Descriptive science doesn't.
No, that's cause and effect.
No, it's not cause and effect.
That's a cause and effect.
Wrong. No, that's not cause and effect.
No, hold on. He put the masses. He moved the masses the other side, and the wheel went the other way. The torsion bar went the other way. Yeah, he pretty much so.
Yeah, that's descriptive science. That's all it is. You're describing an observation. You're describing an observation. You're not isolating the cause.
But he manipulated the variable
just
by
moving just moving the objects around isn't isolating the cause. I'm sorry.
It is actually.
No, it's not. No, it's really not.
Because they moved toward the masses. When you put it on the other side, they move the other way.
That's a description. You've seen the masses move together. Good for you.
How many experiments have you done?
Last time was in high school, bro, in lab.
Yeah, high school. Very good. Thank you.
It doesn't matter.
NASA, you got that demonstration? You got that demonstration, NASA?
Right.
Where's that demonstration, buddy?
He posted it already. Called Cavendish.
Who posted it?
So you have descriptive science that establishes like properties of objects. When we even biologists, they go out there and they observe animals. They describe their mating habits and stuff like that. They might manipulate, the scene or the habitat of the animal. You guys are doing descriptive science, calling it causal science. That's the problem.
But you move the masses, they go the other direction.
And that's a description.
No,
you haven't isolated the cause, dude.
No, that's the cause.
No, it's just relational descriptive science. No, dude, it's not the cause.
You move them the other way, they move the other way. That's the cause.
No, dude, descriptive science has to do with distances, angles, geometry,
geometry,
patterns, biology. We're not doing biology with the Cavendish experiment, are we?
Right. Again, no, it's not biology.
The purpose of this Cavendish experiment is actually to isolate the cause, but it's unsuccessful in actually doing that.
No, it was quite successful.
No, all you have is two masses coming towards each other. That's
right.
all you have. It's an observation and a description. That's it.
Right, well, no, you can measure the force there too.
No.
Yeah, so doesn't mean you've isolated.
That's what it's doing.
That's a description. Again, it's a description.
Blue came up with
you can measure a triangle. You can measure the triangle, see how many degrees it has, and
and calculate the third one.
Until you've isolated the cause, which backs up your hypothesis, you don't have an argument.
Actually, they did. In Cavendish, they did. They manipulated the variable, came up with the cause. Mass attracts mass. He actually measured big G.
That's not manipulating the variable.
It is. It is.
I mean, manipulating the independent variable. No, it's not.
It is.
You had a downward variable too, right?
Well, the downward variable doesn't matter because he's measuring.
Oh yeah, it does. Yeah, because you have a Barry point, right? And it's pulling towards the center, so it could have been pulling it down, right? And closer. If it pulled it down, it would bring it closer together, wouldn't it?
It wouldn't. It wouldn't do that.
That's silly. That's silly.
Now you're just trying to throw shit against the screen and see if it sticks. And I'm saying,
kind of like what you do.
No, not what I do. I have science.
Just throwing shit out there.
Yeah, because you just make shit up. No, you just make shit up. I know you don't like me,
literally what you do. You were telling me I can create a real life representation of an area with the gravity completely manipulated and simulate the Earth orbits in person. That's what you were trying to put forth. That's the lie you were saying.
Somebody said that.
Yeah,
too? I didn't say it.
Yeah, you, Wesley, said you could do it. You said you could manipulate gravity.
We do. Yeah, by moving the masses.
Yeah, yeah, not gravity though. Because if you could, then you could just move the bodies around and you get them to float there in a room and spin around each other and shit while they're orbiting.
Yeah,
that's what you could do if you could.
That shows how lost you are, man.
Yeah, because the 9.1 meters.
It's not being lost. It's saying I can manipulate this thing.
We're not measuring gravity downward. We're measuring gravity sideways. That was the brilliance.
That's downward.
That's okay. No.
Why did you measure for it downward, NASA?
because the 9.1 meters per second overwhelms the very small. See, this is the thing. This is why Cavendish.
All right, so we bring it to the center.
This is why Cavendish, who lived a long time ago, is smarter than you, because he figured out that you don't have you can measure gravity perpendicular to the gravity vector of Earth.
So nothing.
So Nessa, do you think the object that's being attracted to the larger object, where is it being attracted to? To the well, the gravity well around that object, or the center of that object?
Yes, both.
Okay, thank you.
Who wants to go eat some babies? Am I right?
I mean, I was really interested in where Lion was going originally with all this before all the derailment happened.
I don't know.
Really fun convo.
Yeah, you need to be able to manipulate the independent variable to have a proper experiment. As many times as they want to say, no, you don't. All we have to do is move balls around. That's not manipulating the cause, dude.
It is manipulating the ball.
Moving the balls around is not manipulating the cause, dude. That's not. No, that's not. That's not the cause.
You gotta hear him talking, right?
Yeah, I do.
Hear him talking, don't you?
Yeah, he definitely is wrong.
Is there
so why are you constantly disrupting?
So when it comes to logic, right? Whether it's the scientific method or propositional logic, when you make a proposition or when you have a hypothesis, the same thing as a proposition, you need to be able to form the argument that it has to be valid and sound. In order for the hypothesis to be sound, you need an independent variable that is manipulated to actually ground the hypothesis, to make sure that your hypothesis is true, that the conclusion follows. If you don't have an independent variable that you can manipulate, and I'm not talking about moving objects around, that's not the independent variable. When it comes to causal science, cause and effect relationships, you need to manipulate the cause itself as the main variable. No, it's not wrong. The main variable is the cause itself, not the secondary objects and stuff.
What's the variable line?
You're incorrect.
What's the variable
it's
line?
Gravity.
Which they manipulate by moving masses, because mass attracts mass.
No, dude, that's not the cause,
dude.
bro.
Yes,
no, it's
dude.
Not.
Yes,
no,
dude. It's true that mass attracts mass, because when you move the mass, that goes the other direction. Mass attracts mass. If you want to look at the Einsteinian, mass bends space-time.
Yeah, Einsteinian is the bending warping of space-time, not
Same
mass,
thing.
dude.
No, wait, hold on. Again, Newton is a subset of Einstein.
Little pieces of mass aren't bending and warping space-time in the lab, dude. No, it's not, dude.
Yes, they are.
Not verified that to be the case at all.
That's what the Cavendish experiment does.
The thing is with Cavendish, you just have lines, right? You just have an effect. The balls go towards each other. What's the cause of that? Space-time bending. You can't manipulate that.
You do, by moving the masses.
That's manipulating the mass. That's not manipulating. You don't even know if the space-time bending thing is a real thing or not.
Well, the mass
this
attracts
is
mass.
This is like phlogiston.
If you say, again, it's not like phlogiston though, because when you move the masses the other direction, the torsion rod goes the other way. So you're manipulating the variable. I know you guys don't like this, but it's doing that.
It's not doing that. When you set the things on fire, you're igniting the phlogiston. It's the same exact thing. This is the same exact thing as phlogiston. You don't even know if it's real. You don't even know if it's real.
Stop talking over him.
Well, he's wrong. I mean, how many times you guys say
I can't even think straight because all you do is talk through me, dude.
Well, if you would think straight, you'd realize you were wrong, and then you would be quiet. But if I let you talk for 5 minutes, and you've gone at 5, and
all you have is an effect.
And you go 5, and I was talking now, and by the time you finish talking, you've gone through 5 points, and when you start off with the first point was wrong, and everything based on that premise is also wrong.
He doesn't do that all the time.
This stuff since 2015. Nobody's ever proven the freaking stupid Cavendish.
Incorrect. Yeah.
Huey used to spank you guys for freaking years.
Huey's an idiot.
This. It's ridiculous.
He's a moron.
You guys are it's so fucking stupid.
I understand. Yeah, is the best you got. See, the thing about QE is he also didn't graduate high school.
Wow.
His 4-step scientific process is what they taught you in 6th grade, and that's a good start.
How do you think he got into the military if he didn't graduate high school?
You can actually go to the military.
You
can get into the military.
He was a nutritionist.
You need the equivalent.
Yeah, he was a nutrition specialist.
They let Mexicans into the military that have no education.
No, they don't. You need you got to pass the
Yes, I'm sorry to inform you, but yes, they do.
You got to pass the ASVAB.
Yo, Jeremy, you there?
Yeah.
Dude, I'm pretty sure passing the ASVAB is like being. Oh, I don't hear Jeremy at all. No. He was. I interrupted him, and then he. I don't know. He just was talking. Hasn't spoken. Whatever, man.
But the man has a freaking. I believe it's a biology degree.
Well, all we're doing is observing effects, right? With the Cavendish experiment, you have a description on your hand. That's all you have is a description of the effect.
Oh my God! How many times I got to tell you by moving the masses, you manipulate the variable.
No, you don't. How can you verify that it's a bending warping of space time though? Just by moving masses around.
You should thank Huey for his service to his country. That's what you should do. Stop being a bitch.
Yeah, he was a nutrition specialist, a cook. So no.
You're begging the question and affirming the consequent, dude.
Again, Cavendish didn't
how can you be confident that it's the bending and warping of space time? Go ahead.
Again, Cavendish didn't talk about the bending and warping of space time. He was before that, so it was mass attracting mass.
I know that, but it's been replaced by Einstein, and you guys still use it
to prove
Einstein.
Not replaced.
So I'm asking you, why are you so confident that you to the point that you're from the consequent that it's bending and warping of space time?
We're going on getting data. And affirming the hypothesis.
Observational science. That's just step one.
Affirming the hypothesis. What other kind of science is there?
Observation is basically hypothesis based off of a natural observation. You're making an observation in the lab, and you're coming up with a description of masses coming together. That's all you're doing, dude. It's an effect. You're describing an effect. You're describing an effect without isolating the cause.
They had a hypothesis that mass attracts mass, and then they confirmed that with the Cavendish experiment, and they moved the masses around, and mass still attracted mass, and they calculated a big G.
Yeah, but that doesn't give you sufficient reason to then affirm the consequent. Just because you have predicted
power.
Hold on, dude. Why do you do this, bro?
Because you're lying.
Even if I gave you predictive power, you can do that based off of habitual observations.
And they made a hypothesis, and then they went and got the data that affirmed the hypothesis. This is not affirming the consequent. This is getting data.
He just got the data that affirmed the hypothesis. That's definitely.
I know another guy who. What's your?
No, you just said it yourself, man.
Elbow, what's your scientific background?
You just said it, man.
What's your scientific background, Elbow?
You just said it, man.
What's your scientific background, Elbow?
Oh,
I'm actually taking a few
so I have
at the moment.
Go ahead, Noah.
I have a question for Lion. Yeah, I want a question for Lion, actually. Maybe I could play devil's advocate.
No juice stuff today, dude, please.
My question's on topic, buddy.
All right.
Would you agree that Cavendish is showing an attraction between objects, at least?
Yeah, so I can grant them, right, that the objects are actually experiencing some type of attraction, right? I don't know that to be the fact, but I can grant them that. It's not exclusive to relativity.
But I mean, really what you have is an oscillation. It's not even an attraction. It's just oscillating back and forth.
But it is an attraction because it moves.
No, it's oscillating. If it would have been an attraction, it would have went back.
It is an attraction.
It goes back.
It also moves. If you look,
so if it goes back, it's not attracted. Do that with a fucking magnet. Does the magnet go back? No, it will stay attracted to the fucking piece. So don't say it's an attraction when it oscillates.
There is an attraction. It's closer to the mass. It's never further away from the mass.
Yeah.
Wait, they said there was something about an oscillation. Can icy spin maybe? Yeah, maybe someone with actual like class and like ability to speak in a civilized manner, like icy spin. That's a Glober. Is this true? This oscillating, like it doesn't just attract; it attracts and repulses. Is that the case?
No, it moves in a particular vector that's closer to the mass, and it oscillates until it stops moving. And then once it stops moving, it happens to be closer to the mass that was introduced.
Show me one that stops moving. I've always seen it always oscillate.
I posted
you mean a larger mass, right? What if they're of equal mass? Are they not attracted to each other, or is the smaller object attracted to the larger object?
That's the point of the Cavendish. One of the masses is bigger than the other one.
Well, it doesn't matter which mass is bigger. There's an attraction.
Attract one another?
Yes.
What if they're equal?
The Globers agree with Paid that this gives you the cause. This Cavendish thing gives you the cause of the effect, or
mass attracting mass. Thank you very much.
Hello, not you, Paid. Anyone but Paid. Any Glober but Paid. Do you guys agree that this gives you the cause of the effect? This Cavendish thing.
Crickets.
Yeah. So what I was actually gonna mention, for instance, like if you want to find out if there is a greater, if you weigh more at a different altitude, what's the independent variable when you go to the top of a mountain, for instance?
I don't know. Can you at least just answer my thing? Yes, no.
Well, the point is that the independent variable doesn't have to be the cause.
Well, no, you're talking about if you're talking about descriptive
but that wasn't
science.
The question.
Go ahead.
Can you rephrase the question, maybe, Jeremy?
But you're conflating two different types of sciences, right? You have causal science, that's all about cause and effect relationship, where you're trying to isolate a cause, right? And then you have descriptive science, where all you're doing is establishing a property or a description, right? In this case, if you're just moving around, that's not causal science, bro.
But the independent variable is the altitude, and you're not testing the altitude.
Yeah, you're talking about that's descriptive science. That's descriptive science. You're confusing causal science with descriptive science. Two different categories. A category error.
I'm not aware of the difference.
With just plain observations of effect, when you're not actually isolating a cause and all you're doing is changing variables regarding prescriptive science or descriptive science, that's just establishing a property or a description of an effect. You're not actually establishing a cause where you would have to actually isolate it.
So here's the thing, though. Weight change with altitude change. That's the effect, right?
The weight changing is the effect. Yeah.
The weight change with altitude change. That's the effect, right? Hello?
Yeah, but it's not. Yeah, it is. What's your point?
Okay. So do you get a cause from that? Can you just answer my first, before we go on, can you just answer my first question? When you do Cavendish,
I'll ask you to rephrase. Yeah, rephrase that.
All right.
Jeremy, all I was asking you was to rephrase what you were talking about with the Cavendish. I didn't understand it.
Yeah, when you do Cavendish, and you get the effect of the balls attracting each other, do you get the cause out of this so-called experiment of why the balls are attracting?
The answer starts with an N.
I'll play your game because I want to see where you're going. I'm not sure, so I'll say no.
Correct.
No, I was just asking because it's saying a game. Pate said you get the cause out of this. I just wanted to see if the other Globers agreed with him or not.
Well, we might form a hypothesis that says if we introduce a mass to another mass, then what we would expect is that there's going to be an attraction between those two masses, and the masses will settle closer to one another, or something to that effect.
Yeah, that's the effect. Yeah, the masses will get closer to each other. Yeah. My question was, do you get a cause of why that's happening? We know the effect. The masses get closer. Yep, that's neat. Do you get the cause from this? Well, it'd be
objects. They think it's the gravity.
It'd be objects,
Yeah,
not
they think it's
masses,
the gravity
right?
well,
Because you can't put pure mass into an experiment. There's no such thing as pure mass. You're always manipulating an object. So it's not masses attract each other, it's objects attract each other.
I would say the cause would be introducing another mass into the scenario.
That warps space-time, right?
And when you introduce another mass, you get the effect. We know the effect. Yes. You introduce two masses, they get closer together. That's you keep describing the effect.
No. The cause is introducing the masses.
You're thinking it's the cause for some reason.
Right, introducing the masses is the cause, right?
So nothing beyond that. That's the cause. Is just you introduce a mass, and now it's attracted to another mass. Nothing to do with space time at all or anything, right?
Right.
No, that wouldn't. That would be like me putting two hungry fish in a fish tank. Right, I'm putting them there, but one eats the other because they're hungry. It's just because I put them there doesn't make it the cause. There's another cause. So we're trying to get
talking about
the cause.
Yeah, I'm talking about the most bare bones version of what the cause is introducing the masses.
Cavendish was invented before. Cavendish was invented before, or the idea was done before relativity. It was done for like Newtonian mechanics, so it'd be specifically about mass attracting mass, nothing to do with space time.
Yeah, and so the hypothesis might be something like, well, if we introduce masses in this way, right, where we swing it in, whatever, then we expect there to be an attraction between the two of them, plain and simple.
How are you going to add mass without?
Yeah, because they think space-time is warping, right? The object is making a gravity well. So the other object is...
Cavendish was done like 100 years. Cavendish was done like 100 years before Einstein was born.
We can talk about what the interpretation or what the outcome might be on a larger scale, but that's not part of the experiment, I would argue.
What was the point of Cavendish? Did you know?
To get big G, I think.
No,
yeah, that's right.
Not at all. Nope.
I think it was.
No, it wasn't. He was trying to weigh the density of Earth.
Oh, okay. Yeah, I've heard that too, I think.
Yeah, well, he had to assume the volume of Earth, and then he had to calculate for big G. That's what Cavendish was for. That helped him solve for the density of Earth.
Yeah. So then somebody else added the G into it.
You're right, Elbow. At least the AI overview says the Cavendish experiment was significant not only for measuring Earth's density. Well, I won't get into that. But it does say measuring Earth's density and thus its mass, but also for blah 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 about Newton. Right?
Did you ask it about big G though?
I didn't. I just said what was the purpose of the Cavendish experiment.
Try ask it what it says about big G next.
I mean, it does go into determining. Oh, it does say that at the end. Since the late 19th. Here, I'm just going to drop it.
You can just read the last sentence.
I'll read the last sentence.
Just say it.
Since the late 19th century, refinements of the Cavendish experiment have been used for determining big G. I don't know if that's saying that the original idea. It sounds like they're saying that that's what's going on now. I don't know. And it's not part of the highlighted part.
It's supposedly about mass attracting mass, but you could never have a pure mass. Like you can never just have mass and put it somewhere. Mass and objects or matter are inextricably linked. So it's more about matter or objects attracting each other. You can't isolate mass.
And I know what they've done in Cavendish. In fact, Eden pointed it out as a part of the blue marble slide, one of those that I dropped earlier. Anyways, he using different types of mass. A lot of times they use like, I don't know, 100 kilogram lead balls, which don't have they don't have magnetic attraction to any measurable degree. They'll use other things like blocks of ice that are super dense, and things of that nature to show that things with different electrostatic potentials still attract in the same way.
Do you think it has to be stationary for them to attract one another? What if they were free falling side by side? In your opinion, would they be attracting?
Well, there's a lot of variables at play, but maybe in a vacuum, if it was measurable, maybe they'd be closer together if you dropped it from, I don't know. I mean, that's like kind of a theoretical question, right? But like nothing should prevent it from getting closer in a vacuum if you drop it from a distance that you can measure it at, I guess, perfectly straight down.
Yeah. So if we were to ask why are they attracted to one another? Could we say that one object is falling into the gravity well of another object?
No, they just say mass attract the mass, bro. It's like a broken record.
Yeah, I think Lion is right about the we don't necessarily know why the phenomenon happens, right? But they might have the gravity well, and they're able to show how other principles might apply, where they could describe it like a well or something to that.
Yo, is Paid here still? Did Paid hear that?
Who's Paid?
I don't think he's here. I don't think he's here.
His name used to be.
Who said unfortunately?
His name used to be Paid NASA Shill, but people started calling him PNS, which sounds like penis. So then he changed it to NASA Shill because everybody was trolling him, calling him PNS. It used to be Paid NASA Shill for years.
Would he have a problem?
And people either called him Paid, NASA, or Shill. I usually always called him Paid. So nowadays, since he changed it, and there's new people that didn't know that. When you say Paid, some people don't know who you're talking about.
I got you. I'll remember that.
Can we set up a debate between you and Paid on this cause of Cavendish thing? Because you said we don't know why the effect happens. You said we don't know why the effect happens. He said we do know why the effect happens. In fact, we're manipulating the independent variables so much that we know why it happens. Wasn't he trying to say it was because space-time was bending?
Yeah.
I mean, I guess, man. I don't really know how. I mean, I think that we don't actually know why gravity, or even take it to that step, Jeremy. Like, why does space-time bend? Like, we can't really answer that, right?
You don't know if space-time is you don't even know if space-time is a thing or not. Have you ever heard of the word phlogiston?
So if I don't know if it's a thing, then how could I answer that, right? So that's why I would bottom out to like, no, I don't know why.
Well, I mean, how would you know space-time even exists, though? Have you ever heard of the word phlogiston?
No, I've never heard that. Might have.
Shout out
it's
to
kind of
Nate.
like this. Shout out to who?
How do you spell it?
Remember Nate? He used to call his name. He changed his name to Phlogiston. He always talked about it. You know Nate from New York? That Nate? He hasn't been around.
The guy
in a while.
that can't pronounce ours?
Okay, phlogiston theory.
Yeah.
Okay, I'm reading.
It's with a PH.
Yeah, I got it. Pursued scientific theory.
They thought this was a thing back in the day, like space-time. Except they didn't have it. They didn't even know it wasn't a thing, but everyone was running around thinking this shit was a thing. It's kind of like the space-time thing. Like, there's a lot of ideas and stuff about it, but there's never been any kind of scientific evidence or proof or whatever you want to call it that it's even a real thing.
That's incorrect.
What is it?
That's just wrong.
Phlogiston? What is that?
He's back.
That's just wrong.
Have you ever heard of the hold on, I'll tell you.
Who's back? PNS?
Well, at my local
PNS.
science center, at my local science center, what they'll do is they'll have a place where you can drop a penny, and it'll roll around the so-called space-time, and then it'll go faster and faster as it rotates around the black hole. So they do try to explain it, but
so there's an experiment called the gravity probe, the gravity probe B experiment in 2004, where they had 4 satellites. Hold on, I'm trying to get back to the. I dropped it a minute ago in the. They had 4 satellites that had extremely precise gyroscopes, and they ran this test for a year, where they, against a layperson's understanding, they expected there to be a drift there are two phenomena they were studying: the frame dragging effect and the geodetic effect that they made predictions for prior to doing the experiment, which is a part of relativity. And they ran the experiment from like August of 04 to August of 05, I think it was, and there was a drift that was measured that fell within error bars of what their expectations were. So that would be one way that they confirmed relativity. Don't know much more beyond that, but
gravitational lensing.
There's a lot of papers written about this. Sorry, go ahead.
Gravitational lensing. Eddington experiment in 1912?
Oh yeah, was it 1912? Where they were predicting based on the solar eclipse?
Yep.
So NASA, why do you think a smaller object is attracted to a larger object? Is it falling into its gravity well?
Common gravity well. That's correct.
Thank you.
Like the Earth-Moon system has like a barycenter that they both sort of rotate around. It's like the average of the masses and the distance, like it's whatever that particular point on Earth is, where they sort of do a little dance, like they are arm in arm around that little spot.
So, Paige, you said when we do Cavendish, we get the cause of the effect, which is space-time bending, right? When we do Cavendish?
Cavendish didn't talk about space-time bending because it wasn't a thing, it wasn't a theory yet, but yeah.
So we don't get, so you're saying now we don't get the cause of the effect because the mainstream idea is the cause of the effect is space-time. Do we or do we not get the cause? Do we or do we not get the cause of the effect when we do Cavendish?
Yeah, mass attracting mass and space-time bending are the same thing.
Nope. There's reason why. No, they're not. The reason why Cavendish goes together. I knew you were going to interrupt me. I absolutely knew it. I would have put all my money that you were going to interrupt me.
Well, they're the same thing. Mass attracting mass bends space-time, and therefore they fall into the well. Same thing. Different ways of saying the same thing.
Can I ask you this? Like in the Cavendish experiment, what is the cause?
According to the mainstream, it would be space-time bending, right? That's the mainstream idea of gravity is space-time bending, no?
I was doing my best, Jeremy, and I was just asking him that question. What's the cause in the experiment, NASA, like for Cavendish?
Mass attracting mass, space-time bending, say whatever you want.
So he's saying we get space-time bending out of Cavendish, right?
Yep.
Yeah, we do Cavendish, we get the cause, which is space-time bending. Cool.
Or mass attracting mass.
I see spin. When can I set up a debate between you two? When can I set up a debate between you two guys to sort this out?
Saying the same thing. You're just taking nuances and having to say no.
Would the bending of space time be like a more detailed way of saying mass attracting mass, or is it different?
The thing about it is the flat earthers think that Einstein and Newton are two totally separate things when they're not. Newton is a subset of Einstein.
No, they're 100% different, bro. You know F equals an IC. This is for IC spin. I knew you were going to interrupt me again. That's why I was about to say this is for IC spin. Can I just IC spin? Do you know about GR? Do you know about GR?
No.
You don't? All right.
Like,
well, just because Pay keeps saying that, Pay keeps saying this, but it's just not true. Newton, GR. When you drop something or when there's free fall or an orbit, there is no force in general relativity. No force there, zero. No forces, right? But we have F equals ma. And when you drop something in F equals ma, you have mass accelerating and you should have a force there. Newtonian mechanics and GR are incompatible.
Well, doesn't like Einstein's field equations, aren't those like the main principles for describing like how bending and warping of space-time takes place?
Yes, and he described it as no force. However, we know that Newton described mass accelerating as a force. You'll have a force there if you have that. And compatible.
You can derive Newton from Einstein's field equation.
You can't have a force and not a force at the same time. IC spin, aren't those two things incompatible? Could you have a force and not a force at the same time?
Again, you can derive Einstein. You can derive Newton from Einstein.
Not you, dude.
Well, when you're saying force, Jeremy, like I think you're using the term in a way that would be described differently, but to mean the same thing, right? Like in relativity. Because if we're talking about bending, I think bending and warping of space-time would imply that there are some like orbital patterns or something. There's some glue that's kind of like keeping everything on I don't know, on a plane or rotating on an axis or something. Just random.
Yeah, whatever's happening usually. Whatever's happening with space-time bending, it's very specifically described as not a force. Clearly, like you said, you didn't know about GR. Like I don't know if you want to start debating me on it, but
It's clearly described as no force, zero. There's no force there. Free fall, orbit, whatever.
But like on the principle of like if something's traveling on a straight line, like nothing would cause it to deviate, aka bend from that straight line without a force being involved, right? Like if
yes, Newton. Congratulations, Einstein also debunked Newton's first. Not only did Einstein debunk Newton's second law of motion, he also debunked Newton's first law of motion. Because things don't go in straight lines anymore. So hold on, things don't go in straight lines anymore. They won't go forever without a force acting on them. All but Newton's third law got smashed by GR.
Geez, Jeremy, what's your Nobel Prize for this? This is new stuff to me.
This is just common knowledge. I mean, you could listen to Feynman lectures. Feynman and Shanker talk about this stuff all the time. Like this is not new stuff. This is well known in the scientific community.
You think Feynman agrees with you that Newton and Einstein disagree with one another?
Yeah, there's quotes from him saying so. Yes.
No.
NASA Shield, do you think you'll ever give up on flat Earth, or is this a lifelong commitment for you?
Oh, I've given up on flat Earth a long time ago. I've been asking for positive evidence for the flat Earth and still not getting any.
You're not giving up.
It's a religion, as near as I can tell, because you guys have beliefs without any evidence.
You're a card carrying member. You're a member.
Get that projection going.
Yeah, it says guys who don't understand science, right? Got it.
If you think it's a religion, you're showing up for sermons every day.
I just come here to see if you guys come over to the if you're still worshiping the Church of the Dark Side or not.
The Globe is the dark side, though.
No. The Globe is the scientific. In order to
science though for the Globe. What are you talking about? The scientific side.
Science. Like Cavendish.
You guys disagree. You and IC Spin disagree on the science of Cavendish, though. So
no, not really.
What is it?
Not really. No.
Okay, you think we get the cause of the effect, which is space-time bending, and IC Spin doesn't think so unless he changed his mind in the last 3 minutes.
No, I mean, I can tell you exactly what I said, and everyone in the room heard it. All I said was the cause was introducing the masses.
Got nothing to do with space-time. You don't get anything to do with space-time out of it. Paid thinks the science is we get space-time out of Cavendish.
You can explain Cavendish with space-time. Cavendish didn't know about space-time because it wasn't invented during his time. He proved that mass attracts mass, which is we now understand that mass bends space-time. The same thing, two different ways. This idea that Einstein and Newton don't like one another is it's like Salieri and Mozart.
It's a real art, the ability to hold two contradictions in your mind at the same time. It takes a lot of skill and practice.
Yeah, you should try it sometime, You try to understand that it's not happening the way you think it's happening.
See, I'm going to post a picture for you in the live stream.
Exactly, like the meme I have with the phones dropping. Yeah, they're able to do this. It's astonishing. The Earth moves upwards, but the ball doesn't grow. It's like I said, it's astonishing.
It doesn't move upwards. Stop saying that.
But you're talking about four-dimensional movement, and you're talking about four-dimensional movement, and you're only including 3 dimensions in your picture. Actually, that picture's only 2 dimensions, by the way. So,
yeah, I mean, according to PhD levels, they don't know if the ground's moving up or the object's moving down when he drops something. So I don't know how you know the ground's not moving up.
Yeah, it's called relative motion. Yeah, that's when the apple falls off the tree, and from the apple's frame of reference, it's just hanging out in space-time, and the Earth is rushing towards it. Yeah,
I know, but someone just said the ground's not moving up. Like he don't know that. Because even PhD levels don't know if the ground's moving up or the object's moving down. So,
Pure Rigor, please post a citation of that, because you would obviously know that if you saw that somewhere. So go ahead and post a citation of that, unless you're just floundering like usual.
Are you talking to me?
Oh, was that not Pure Rigor? You sound too much like him. Jeremy, post a citation of that.
Of what?
You said that PhDs don't know which way the ground is moving.
Yeah, when you drop something, they don't know if the ground. I don't have a citation. John, you know that guy John that has the PhD that comes around?
No.
This is a.
You don't know the PhD guy John? He's got PhD in physics. Last time he was here, he told me he doesn't know. He said it's silly to even ask which one's really moving.
Well,
you guys don't know. You guys don't know if the ground's moving up or the object's moving down or it's both. You have no fucking idea.
No, they do, but motion is relative. You have to compare the two.
Right.
I know. That's what they kept saying, and they kept saying that we don't know which one it is. It's relative. You could say it either way. They don't know. But you just said the ground's not moving up, like you knew the ground wasn't moving up. But in your paradigm, you can't know that.
So
from the apple's frame of reference, falling off the tree, it's just hanging out in space time, and the Earth is rushing towards it. That's not incompatible with what everyone's saying.
And then from another, from one frame the ground's moving up, from another frame the apple's falling down. You guys don't know which one it is.
Right.
Yeah, you guys don't know which one it actually is. But he said a statement just now. He said a statement just now like he knew which one it was.
Jeremy, it's both at the same time.
That's fucking retarded. That's the stupidest thing I've heard all day.
Why is that stupid? Why is that stupid?
They can't be both at the same time.
Yeah, sure. The reference frame. From
the ground can't actually be moving up and the apple's actually moving down at the same time.
From what reference frame?
Unless you're getting half of the 9.8 on both ends. You could do it like that.
From what reference frame are we talking?
I'm talking about what's actually happening in reality. That's where you guys... I know you guys don't know what's happening in reality. You have to do it according to the reference frame. I know that was my whole point. That was my whole point. That was my whole point is you guys can only do it from the reference frame. You don't know which one's actually... You don't know which one's actually moving. However, somebody just made a comment like they knew which one was moving just now. He said this ground's not moving up. Like that was crazy. Even though in the mainstream paradigm, you have no way to know that.
Because the picture that he was talking about shows the Earth expanding its radius, moving up in all directions, and that's not happening. That's what he's trying to say.
But
from the reference frame thing, both are happening at the same time. From the apple's reference frame, it's just hanging out in space time, and the Earth is rushing towards it. From the Earth's reference frame, the Earth is sitting still, and the apple's falling towards it.
And you don't know which one's actually moving in reality. I know.
Both are happening at the same time.
That's my whole point. That's my whole point is you guys don't know which one's actually happening. Yes.
Well, from whose reference frame? Both are happening. It depends on the reference frame.
I know, but only one of them can actually be happening. And
why? Both are happening.
Are you saying it's 9.8 meters per second squared, cut in half, the ground going up half, the apple falling down the other half?
From the reference frame of the apple, it's just hanging out in 3D. It's hanging out in 4D space time as the Earth rushes towards it at 9.81 meters per second.
And you don't know which one's actually happening in reality.
They're both happening. Depends on the reference frame.
No, they can't both be. You can't have the ground moving up because you can't have the ground moving up and the apple moving down at 9.8 meters per second squared because then it would be a faster bro, I can't do this with you interrupting me every time I talk.
Stop interrupting, NASA. Stop interrupting, bro.
So if I'm on an airplane going 600 miles per hour and I look down, I see the ground going past me at 600 miles per hour. But someone on the ground looking up the airplane sees the airplane going by at 600 miles per hour. Which is what's happening?
You guys don't know. I would know. I know the answer to that. You guys don't know which one's actually moving.
It could be which one's happening.
Bro, I don't know. I can't with you.
Which one's happening, Jeremy?
I said, do we have to mute you, bro? Do we have to mute you?
Which one's happening? You say you know which one's happening, and then you peter out.
Yes, we know.
So go on mute and let him answer without interruption. Let's see if you can do that.
We know how airplanes work. We know that the airplane is moving, and the guy on the ground is just still not moving. We know that the people on the airplane. We know that the people on the airplane aren't still, and the ground's rushing under them at that speed because you could have two airplanes go by each other. Like we 100% absolutely know what's happening in that scenario because we know how airplanes work. We fucking built them.
From the perspective of someone on the ground, they're standing still in the airplane's rushing thing. The perspective of someone on the airplane, they're pretty much hanging there in the air as the ground goes underneath them.
Right, but in reality, we know how planes work in reality, right? So we know that that it's the airplane going over the ground and not the Earth because you could have two airplanes go past each other. Now what's happening?
Both reference frames are equally valid.
What's happening when two planes go past each other?
Two airplanes are coming toward each other. How do you know which one's moving faster?
How do you know which one's moving faster?
Yep.
I don't know. You can measure the ground speed or something.
No, without.
I don't know how you know that. I don't know how you know that. That doesn't defeat the point. Yeah, perfect. That doesn't defeat the point that. All right, go ahead, man. You're on some paid NASA shill interruption shit. Go ahead.
Maybe I'm delayed. I'm sorry.
You want to do lead and follow?
Go ahead.
Where you lead me for 5 minutes and then I lead you for 5 minutes? You want to do that?
That's a great idea.
Yeah, I don't know what that is, but whatever. So again, if you were the two planes going toward each other and no other reference to tell, how would you know which one's moving faster if they were approaching each other?
I don't know, but that's not the scenario that I just pinpointed out to where we can absolutely know if it's the plane moving or if it's the whole Earth going by underneath them at that speed. We definitely know that one, right? Do we definitely know which one's moving in that scenario?
Nope, because you're assuming that you're still when you're on Earth.
So you don't. So if we have two planes, they're going 500 miles an hour, and they go by, they're coming at each other. One's higher than the other one or whatever, and they pass each other. The ground couldn't have been going one way for the one guy, another way for the other guy at the same time. It'd have to be going two different directions at the same time. That'd be nuts.
It looks like it looks like that. To the one guy, it's going to the left. The other guy is coming at them. Both of them, the ground is coming at them.
Yeah, I know what it looks like, but I obviously can't be that because A, we know how planes work, and B, the ground couldn't be going in two opposing directions at the same time.
Right. It depends on your reference frame. Are you on the ground, in a plane, or in the other plane? That's exactly what relative motion means.
Yeah, it means you don't know what's moving. I know. Even with a tree in a car or the plane scenario, you guys never know what's actually moving in reality. You only know what it looks like it's doing from this specific limited point of view where you don't have any other contact with other humans or know anything else ever.
Yep. If you were on the moon, you would say that the Earth is definitely moving and the moon is stationary. If we all lived on the moon, we would say that. It's just what you're used to.
It's a neat scenario, but in the meantime, so you're telling me we get a plane in the air and you don't know for sure if it's the plane moving at 500 miles an hour or the ground going 500 miles underneath them?
No, if you were at a stationary point in space, it would be looking like it's going at 1,000
No, we're on
miles.
a plane. We're on a plane.
So from the perspective of the plane, you're stationary.
No, the question is, do you know what's actually happening in reality?
From what
not what it looks like, not from the perspective of this person. Do you actually know what's moving in reality? Is it the plane going over the Earth at 500 miles an hour, or is the plane stationary? That would be very awkward. And the Earth's going under the plane at 500 miles an hour.
The only reason it's awkward is because you're used to living on the surface of the Earth.
Can you answer the question, please?
The question is, it depends what reference frame you're in.
I know. No, that's not the question. The question was, do you actually know what's moving in that scenario or not? Not what it looks like from one person's point of view.
Motion is
you don't
not.
know if,
Yep, motion is not absolute.
So the plane could just be still in the air, and it's the ground moving under the plane at 500 miles an hour.
Yep, you got it.
Yeah, that's fucking stupid, bro. It's dumber than the shit Paige said 5 minutes ago.
That's because you're used to being on the Earth, and so everything moves in relation to the Earth being still.
Nah, homie, it's because I know how planes work. No, it's because I know how planes work. That's why.
When a plane's going 500 miles per hour, what does that mean?
It means in 1 hour it's going to go 500 miles. I don't know. Is that a trick question?
Yeah, 500 miles in comparison to what?
Anything.
Nope, not the air.
The ground. The ground.
Okay.
500 miles. Exactly. We know how to measure distances on Earth. Do we not? So now we don't know how to measure distances on Earth?
Nope, that's relative. You just said it. It's relative to the ground.
Do we know how to measure distances on Earth?
Yep. So that's relative to the ground.
So we would know if the plane moved 500 miles an hour.
I know you got to talk over me, but what's the airspeed now?
So we would know. So seeing how we know how to measure distance on Earth, we would know if the plane moved 500 miles or not, right?
To the ground, but what about the airspeed?
They use a pitot tube for airspeed. I don't know what that.
Okay.
That's not. They use a pitot tube for airspeed. I don't know why that's not even a. Hey yo, blah 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 blah. Hello. I don't know why that's even relevant. We're talking about. Right, because you did the same thing. Like I tried to get a quick answer out of you earlier, and you wouldn't let me do it. And now you wanted to get a quick answer out of me. That's why I wanted to do lead and follow, because we could do 5 minutes apiece and get through with those quick answers real quick. That we want to try to go bring the other guy to a conclusion, right?
All right, you need to tell him what that is, though. He probably doesn't know what that means. Lead and follow.
Yeah,
I'm about to be aside in a minute here.
Yeah,
it's like cross-examination or something where you're fucking
that's fine.
leading the witness.
Well, it's kind of basically like if people agree to it, one person could lead the other, meaning just they could interrupt them, they could ask questions, they could be really quick, they can drive the questions, the topic to really try to get to a conclusion, like kind of like a rapid fire question and answer, but they could like interrupt, they're kind of like leading it, and then you could flip it and flip the other way, so and switch places.
Yeah, it's interesting. In the airplane example, we have two different speeds. We have ground speed and we have airspeed, and that's just another proof that motion isn't absolute. So you could be moving at a different speed to the ground as you're moving different speed to the air.
I mean, I don't know why you think motion is not absolute. Let's say we had lived on a globe with a fixed radius of 3959, right?
Yep.
And that radius didn't change. And then we go to every square inch of Earth, right? Every square inch, somebody drops a little. Let's use an apple. Somebody drops an apple every square inch on Earth, right?
Yep.
And the radius doesn't change, but the apples all hit the ground. Did the ground move up or did the apples move down?
It depends if you're the apple or the ground.
Well, the radius didn't change though, so obviously the ground didn't go up towards the apples. That'd be impossible.
Not to the apple. The apple seems like the ground moved up toward it.
No, I know, but we know the radius is fixed. So we know that opposing sides of the ground aren't going to move away from each other. So if you're all over the whole planet Earth and everyone drops an apple at the same time, we know for sure that the ground didn't move up because the radius would have changed, and that's not happening because we have a fixed radius.
Okay, but you could be in a place in outer space where it looks like that's why your reference frame actually matters. I agree with you that the radius isn't getting bigger, but from that apple's perspective, it does look like the ground is moving up toward it.
Yeah, we know things look like things that they're not all the time. It's not really relevant what things look like. We're talking about what's actually happening in the physical reality.
I just posted an image. I just posted an image for you guys in the live stream if you want to see if it's relevant.
That's why relativity is a thing, right? It's very complex and it's very hard to understand, but that's the whole notion behind it. It depends on your reference frame all the time.
I'm just saying, bro, the top level PhDs, you guys never know what's moving, even though there are situations where you can definitely know what's moving.
From a reference frame, I agree.
No, see, the thing is, you want to limit yourself to this one little reference frame and not know that the Earth has a fixed radius and you can't communicate with anyone else. You want to put yourself in a box and be like, this is all I know right now is I see this. That's stupid.
Well, we know for a fact that the Earth is accelerating upwards. This is a measurable fact. We also know that the radius doesn't change. So it does absolutely depend on your reference frame.
The Earth's not moving upwards.
I know it's accelerating upwards.
Yeah, so you're saying we have accelerating with no movement?
Correct.
Remember when I said 2 minutes ago that was the dumbest thing I heard today?
I know, because you don't understand relativity and the bending and warping of space-time. It's even hard for me to fully understand it too, but it is a thing. It's provable and testable.
So something that is literally not moving at all is
accelerating. Yeah, that checks out. That checks out.
Yep. It's called the bending and warping of space-time.
No, well, the sun is literally moving because of the bending and warping in space-time.
I don't know what you mean by that.
Well, the Earth is moving and accelerating.
Okay.
I think the major overarching point here is you guys never know what's actually moving in reality. And I think we all agree on that. We all agree you guys never know what's moving, yeah.
Yep, there's no absolute motion. It's all relative.
Yeah. So you guys never know what's moving. So anytime some scenario comes up and we're debating about some kind of movement, I feel like you guys shouldn't even be in the debate because you never know what's moving, right? I mean, what the fuck?
Yep, it's all about your reference frame. But because we're on the surface of Earth, we always use that as our reference frame for the most part. So it's weird to consider it elsewhere. But that's what's cool about relativity. That's what's cool about relativity. A free fall, you're not actually accelerating, which was kind of one of the bases for Einstein's theory. You can actually measure that you're not feeling a force when you're falling. You're not actually accelerating. So that's what's kind of freaky about it all.
If you drop something and that's not actually accelerating, then the ground would have to be moving up, not accelerating up with no movement. That's fucking dumb. The ground would actually have to be moving up.
No, accelerating.
4-dimensional, Jeremy.
No, dude. If you drop an apple and you say the apple's not accelerating at 9.8 meters per second, what's it doing?
It is compared to the ground, but to the apple, the ground is accelerating up toward it. And we are, Jeremy, do you believe that force equals mass times acceleration?
Yeah, I think Newton got it right. Yeah.
Okay, so then why do we weigh things? Why do we weigh on Earth?
Why do we weigh on Earth?
Yeah, why do we have weight? Why do you and I have weight as we stand or sit here?
Why do we have weight? I don't know, because things weigh stuff. I don't know.
So do you agree that weight is a force?
Sure, I'll go with weight's a force.
Okay, so force equals mass times acceleration. We have weight, so we must be accelerating.
You don't know what's accelerating. You talking about acceleration with no movement? That doesn't mean anything to me, dude. That's gibberish.
Okay, you just agreed with me that force equals mass times acceleration. You agreed that we weigh something, so we have mass, so acceleration can't be zero. So we are accelerating on Earth.
Can you just give me the definition of acceleration real quick?
Yeah, meters per second squared.
That would be something's moving, an amount of meters per second squared. Right? So acceleration is movement. It's something actually moving in a direction.
Correct.
You just told me Earth was accelerating up, but it's not moving.
In 4 dimensions?
Yeah.
There is no 4 dimensions. We only live in 3-dimensional space.
So that's not
we only live in three. There's only
time.
Yeah, it's right now. It's 11 o'clock. Later, it's going to be midnight. That's not a spatial dimension that things move in. That's just what time it happened. That's just what time it happened in. That's not a spatial dimension that things move in.
Correct. It's a dimension though. It's a dimension though. Yep. And we can prove it because we can slow time down in rhythm.
Slow time down? What?
Yeah.
Really?
Yeah.
Yep.
Just have to move really fast.
Your incredulity elbow matters not in this situation.
Yeah, that was proven by the.
How much did you slow down time?
Well, depends how fast you want to go.
Where did you slow down time at?
How fast do you want to go?
The
You don't even know if you're going fast or not because you don't even know if you're moving.
Do you think clocks? Do you think
acceleration?
They showed it. They showed it going in airplanes. They showed it going in.
Hold on, PNS.
No. Hey, Dick.
Hold on, PNS.
Hey, Dick.
Do you think time is
that
a
bothers
clock?
him.
So they showed on the airplanes the time dilations by putting the remember
Again.
the clock they put on the atomic clock they put on in Pluto?
Do you think that the clock is time?
Clock measures time.
Yeah, but the malfunction of the clock doesn't mean that the time slowed down.
Is a ruler
it's
length?
Just a malfunction in the actual clock.
Nope, wasn't malfunction because when they put it back together. Because when they stopped it and put it back with the other clock, it started keeping perfect time again.
Again, do you think the clocks are the time?
Clocks measure time. Is a ruler length?
Wasn't there something like the way they measured like the decay of like a cesium atom or something?
By vibration.
So
what is between two hyperfine levels?
What is the cesium atom doing?
Transitioning between two superfine transition levels. Doing about 9 million times a second, I think. If they define a second as how many transitions it does.
NASA, what do you think about time travel with relativity?
You can move forward in time.
It's not an answer.
It is.
No, it's not.
Yeah, it's move forward in time.
So you don't want to answer?
I answered.
Like you approach the speed of light, I think that that time
what it is?
You basically go out, and if say you were going the speed of light or close to it, and you went out for like 10 minutes and you came back to Earth, I think it's like, I don't know, 1,000 years in the future or something.
So Jeremy, if you rewind your clock or your hand watch or your phone, you just travel back in time. So because they measure time, therefore, time dilation and time travel exists.
Yep, that's why we have to change the clocks on satellites to match the Earth time.
Yeah, but you can go backwards too in theory. That same theory means you can go backwards. If you can go forward, okay, then you should be able to go backwards.
Nope, can't go backwards. Sorry.
What exactly? Why not?
Because you can't.
Why?
You can only slow down or speed up time. Yeah, you can only slow down.
You can't. That's not an answer, NASA.
Haven't you heard the song, Pure Rigor?
Stop.
I could turn back time. Yeah, see, they know they can't.
So why can't you go back? Why can't you go backwards?
Why can't you walk on the ceiling? Why can't you walk? Why can't you walk on the ceiling?
Just shut up. Hit the.
Why can't you walk on the ceiling? I mean, I really want to walk on the ceiling.
Why don't you hit the eject button into the ceiling?
Why can't I walk on the ceiling? I really want to.
Why don't you answer a question? What are you
because
doing?
I just answered the question. You can't go back in time.
You didn't. I said, why can you not?
Because it would imply that you have negative. Other than the fact you can't. I mean, how do you explain something that's impossible?
You don't know. Just don't answer if you don't know.
It's impossible to do. Why would you expect to do something that's impossible?
Because in theory, it's possible.
Show me the theory that says you can go back in time.
CTC.
CTC. What's that?
It's your time travel and relativity.
CTC.
It's the same thing you're talking about when moving forward in time. Well, you have no idea about any of this. You just wing it.
No, I'm just winging it. Says the guy who says you can go back in time and says
how do you know about moving forward, but you don't know about going backwards?
You can't go backwards in time.
Exactly.
How many people are in the
but
room
you don't know that.
You can't go backwards in time.
You know about going forward, but you don't know why there's a limitation going backwards.
You can't go backwards in time.
The same theory. It's called CTC. NGR.
CTC?
Google it.
What's that?
Google it.
I'm
I'm not here to teach you.
Oh, you're not here to teach me because
you're here to play the teacher like you do day in, day out while you talk down to everybody, right? And then I realize you don't know what you're actually talking about. I call you out on it, and now you want me to teach you. No, I thought you were the teacher.
I'm not the teacher.
Obviously.
Closed time-like curves.
Okay, so why can't you go backwards?
Let me see if I can figure out.
It works in theory.
You go back in time in theory?
You're not going to have an answer. So stop playing pretend like you know what you're talking about and talk down to people.
How do you suppose we could go back in time, Rigor?
I don't.
Okay.
The theory does.
No,
no theory doesn't say that.
Okay. Now you're just lying.
Go
the
ahead.
Theory does not say that. Where's the theory say that? Show me where the theory says
I just told you what the theory is.
What's
you
that?
just told me you're
Oh, so
misunderstanding
deny
the
it.
theory.
Yeah, deny it. That's excellent.
So show me. No,
So
it's
just deny
denied.
thing.
You made the claim. Show me. You made the
Boring.
claim. You made the claim.
Oh, it's a closed time-like curve. Is that what CTC is?
That's what he's saying it is.
Path of space-time that allows for theoretical time travel. The world line is a closed timeline. Curve loops back, meaning past events don't change with time travel.
We can only slow down or speed up the time. We can't go backwards.
So we're sort of talking about like a scenario like the Ghost of Christmas Past or something, like where you can go back and watch yourself, but you can't change it. I think Rigger, by the way, I think he has me muted, just so you guys know, because he doesn't like me.
Rigger, do you have Icy Spin muted?
Yeah. Why do I want to engage with that clown? I've had enough.
Please don't do that.
Am I chopping him?
Yeah, you're talking right through people, so you need to have them unmuted in chat.
Yeah, I'm not unmuting him. I'll just tap out.
Okay, good. Thank you. Bye.
Yeah, run.
That's the guy tapping out. Okay.
I can see him light up too, by the way.
Let me ask you, do you actually believe you can have acceleration without motion? Or is it because somebody told you and you think it's too complicated for you to understand, so you'll believe it? Which is it? Do you actually believe it?
4 dimensions, Jared. SE.
How do you define acceleration, SE Montreal?
What do you mean? How do you define acceleration?
No, you specifically.
You're actually asking me that question?
Yep.
Yeah.
You're going at a certain speed. You press the gas and you accelerate.
Well, acceleration is change in speed or direction. Would you agree with that?
Change in speed, yes.
Not just change. To be more precise, it would be an increase of a velocity. No.
It would decrease. That would still be an acceleration.
A decrease is still acceleration.
Okay, thank you.
But also a change in direction. So like an orbit, right? Like a satellite is constantly accelerating, even if it's going the same speed.
So this is what makes you believe it? So if I tell you I'm going at 60 miles an hour with my Mustang, and I press the gas and I accelerate to 90 miles an hour, can I then tell you I'm not moving?
You're not. Well, if you stay at 90 and you continue going the same direction, well, for all intents and purposes, we can say that you're not accelerating. Yeah.
That's not what I asked you.
Okay, ask it again in a better way.
If I'm in my Mustang and I'm going 60 miles an hour and I press the gas and I go up to 90 miles an hour, and during that period of time, while I'm accelerating, can you say I'm not moving?
No.
So there you go. You proved yourself wrong.
Elaborate.
Well, you just admitted. While you're accelerating, you're moving, but then you also believe that you can be accelerating and not moving. So you contradicted yourself.
Never said that.
It's like a paradox.
Never said.
I mean, it's mind-boggling how you guys can believe this stuff, but hey.
It's simple. Acceleration is a change in speed or direction.
So there's a negative acceleration, which means a slowing down. So it's not really.
Which is still it's negative acceleration.
So it's not acceleration itself; it's a negative acceleration, right?
Yeah, just type in your address bar acceleration and just tell me what it says after you hit enter.
Speeding up.
The scientific
when an object speeds up, the acceleration is in the same direction as its velocity. An increase in speed, acceleration, when an object speeds up, and then a decrease in speed is deceleration or negative acceleration when an object slows down.
You never mentioned
acceleration.
direction,
The scientific term for acceleration is a change of speed.
Yes, but then you got to have the caveat of adding a negative acceleration or deacceleration, where you're actually changing the word, right? Now it's deacceleration. But
no, it's still acceleration. It's still acceleration.
No, it's negative
just
acceleration.
negative, which is still acceleration. It's just you're just qualifying the term acceleration.
It's okay. We all agree with it's.
I mean, yeah, for all intents and purposes, you can say you're slowing down, you're decelerating. It's still, when we're looking at it scientifically, it's still an acceleration. It's simply a change in speed or direction.
So maybe this might make it a little bit easier. So when you're in free fall, you probably won't. Everybody won't agree with this, and that's fine. But when you're at free fall, you don't weigh anything. You are weightless, and so therefore you're not accelerating. You are accelerating in terms of the ground, but we're in the free falling inertial frame. So when what the Earth is doing, even though it's not moving, it's preventing you from still free falling. So that's where we get the acceleration from while it's not moving. It's just a better way of explaining it in my mind when I look this up.
The Earth is always
take
moving.
the second example you gave, icy spin, an orbit. You claim that you can orbit and not have motion because you're accelerating constantly. Is that your argument?
I think you have motion by definition when you're orbiting.
But before you said you used that as an example.
Right, an example of how you're constantly accelerating. Like you might hear constant acceleration like tossed around, and it's likely in reference to an orbit or something like that.
So you are in motion though under that acceleration.
Yes, you're always in motion if you're accelerating.
Just be careful.
You admitted that because before you were saying the opposite. Okay, I'm glad you changed your mind.
If I did say the opposite, it was my misunderstanding. So yes, if you're accelerating, you're in motion.
You believe that, Wesley, or you want to go against him?
Just be careful. Motion is not absolute. Motion's always relative to something else.
That's true.
I knew he would. So, like Jeremy said, maybe we should set up a debate between you guys because you seem to have
saying the same thing.
opposite opinion. And that's going to come in and save the day.
They're saying the same thing
while I'm talking.
They're saying the same thing though. The problem is your misunderstanding of what they're saying.
That's gaslighting 101.
I'm misunderstanding.
That's not gaslighting. Not gaslighting at all.
Tap out, please.
How come you can't go back in time, NASA?
Why can't you be intelligent and make sense?
It's not an answer. It's not an answer.
It is.
No. So you don't know the theory.
Rigger, did you really mute?
Wesley, how come you can't go back in time?
Did you really mute Icy Spin because he got a mod and you didn't? Is that why?
Yeah, paint that picture. Okay.
Wow.
The dude's been muted for how long now?
Crazy.
Because of what he did with Owen and he exposed himself. You want to get into that? You want to get into Icy Spin exposing himself for the gang stalking behavior he was pulling with Owen, and then you want to act like he's muted. Why?
Yeah, let's go back to your question, Pierre.
Yeah, so how come you can't go back in time?
Not been observed. There's a theory that says you can. Prove that theory, you'll get a Nobel Prize.
No one's gonna prove that theory.
Right.
Cool. Nice.
Right.
Plan.
So you can't do it. So you think the theory's wrong?
Yeah, hasn't been.
Okay. So why are you supporting the positive of going forward?
Because that's observable.
We experience it.
Okay. So all this theory is based on the same thing, right? The same idea. It works going forward, but doesn't work going backwards, and you think it's correct.
That's correct.
Okay, so it's supported in a biased direction that you can argue for, but you ignore the consequence of it. Dude, you hear me fucking talking. I know you do.
The arrow of time.
I know your headphones work.
Yeah, except that you.
Yes. So that means like when I go to talk,
I thought you were done,
yourself.
but you continue on.
No, it was clear I wasn't, dude. I was in the middle of the sentence.
Gaslighting you.
So one.
There's parts of a sentence, right?
You want to say over when you're done, so we can be like radio here.
Usually when you hear the end of it, then you start.
So you're gonna complain if I mute you?
Well, I mean, if he's gonna say like, say something, then say over, and I'll be. We can do that like radio.
Just wait for silence. It's simple. See how I just did it, and now I'm chopping you.
Wait for silence. That's a good one here. Yeah.
Yeah, that's pretty much it. So you can't go backwards. Why?
Not been observed.
Right. Why can you not go back in time?
Hasn't been observed. There's a theory that says you can. Hasn't been observed.
Okay, so because you can't observe it, you can't do it.
You can figure out how to do it. Tell you what, you've got to figure out how to do it. And will you please invite me to when you go to Sweden? Because I always wanted to meet a king when you get the Nobel Prize for Physics.
I invited you to answer a question, and you're just choosing not to.
Answer the question.
Hey, this is still going on.
He won't let go of it. He's like, for some reason, he's impossible to understand that the answer is we haven't shown it to be true, and he doesn't like that answer.
Okay, so an observation does not mean it can't happen. I'm saying I want to know if you understand why.
There's a theory that says it can happen. It hasn't been observed.
So that's
would involve negative time or negative velocity of light or something. You'd have to have some negative in order to do that.
So you don't know. All right, cool.
Do you? You don't know either. You're just according to CTC.
Yeah, I do. But I'm not here to teach you. I just want to see if you're full of shit or not.
No, you don't know.
And it's apparent that you are full of shit.
Yeah, it says the guy.
And Wesley. Wesley too. Yeah.
He says the guy who don't explain anything.
Yes, it says the guy that doesn't understand CTC. It's a theory.
Nothing of it, and you say I don't understand it.
Well, it's a theory.
I knew there was a limitation to it. I knew there was a problem with it, but you didn't.
It's a theory.
And then you're gonna look at this like I don't know about it when I had to tell you what it was.
It's a theory. It's a theory. Who's that whining? Who's that screaming? It's a theory.
Thank you for talking.
An unproven theory.
Go ahead, Nessa. Well, Nessa, okay, how about this? We can settle the debate. You know that image that I posted with the globe and the apples falling to space, falling from space towards Earth? We understand the reference frame. It can appear that the gravity, if they were both dropped at the same time from the same distance away from Earth, we understand the reference frame from would appear in one of those frames that the Earth is accelerating upwards. But we can actually determine that the apples are actually in motion.
From whose reference frame?
No, not any reference frame. We just want to determine which of the two is moving. and we can determine that from both ends of the, let's say if we're at the north and the south, we know that it can't literally be moving northern and southern at the same time. So we have to draw the conclusion that the apple is actually in motion.
You have a two-dimensional picture trying to explain three-dimensional movement that's actually happening in 4 dimensions, and what?
But essentially, we want to determine that the apple is actually in motion.
All motion is relative.
Okay.
In that reference frame, both apples are moving towards the Earth, and the Earth is not moving in that reference frame.
Yeah, reference frame of the Earth. That's correct.
Okay, Boomer.
The reference frame of the apples, they're just standing there in 4-dimensional space as the Earth moves towards it at 9.1 meters per second per second.
This acceleration without movement is quite amazing that somebody could believe that. Astonishing, really.
Well, it's actually downward. It's actually downward pressure. Once you hit the Earth, your force equals mass splatters you on the Earth. Your guts and all your intestines and that are now sitting on the Earth at accelerated pressure. It's not actually a movement per se, as in movement away. It's just the downward pressure still is maintained. That's the best way I can explain it. It's reasonably rudimentary. I think also a lot of people say this fourth dimension of time. I think it was Brian Cox explained it like space-time. It's actually still 3 dimensions per se, as in height, width, and length, or left, right, up, down, back and forth. But time is actually more like the denominator. So your numerator of the fraction is height, width, length, and the denominator is time. Because without time, you can't move up, down, left, right, or backwards and forwards. So you've got to have the space movement, which is reasonably consistent, in order to have the left-right movement, the up-down. And that doesn't go backwards, forwards. It's not a dimension per se. It's more like the denominator of the dimensions. Does that sound cool? Well, thank you, guys.
The evidence of your acceleration is just your weight. Simple. It's constant downward acceleration.
All this talk of acceleration, still this conversation goes nowhere.
Absolutely.
Yeah, that's all by choice and by design.
It's a 4-dimensional universe, and people are having a difficulty with it.
Accelerating into the abyss of a black hole.
Well, do you guys ever think it's kind of like, as fascinating as all the theoretics is, it's like answering a question that nobody asked in a weird way, you know what I mean?
I find it fascinating that they believe that. That's what I really find fascinating. But yeah, I get what you're saying.
It's not belief, Jesse. It's scientific fact, scientifically proven. What are you talking about?
You guys have any thoughts about Artemis 2?
Glad nobody was talking when you started NASA. Thanks for that.
Yeah, gay. Artemis. Good luck with that. Are we going to the moon again, boys, or what?
Yeah,
we're going to really do it this time, right, guys? We're going to really do it this time.
In a month.
The cool thing is there's like astronauts going this time, right?
Yeah.
Fuck yeah. Fuck yeah, dude. Fuck yeah.
Or enemies
of the state. Woman aboard this one.
And an African American.
So it's not, you can't call it gay.
Women can't be trusted though, right?
Is she getting equal pay? Oh yeah.
I think so, yeah.
Equal
pay.
Yo, I wonder if shit really hits the fan, if she'll be allowed to vote.
Yeah.
Like, no, Sharon, shut the fuck up. We've got an emergency.
Well, all those billions, man, they can't keep the ship from leaking fuel. I mean, yeah, they're on their way.
I don't know what I'm saying. Like, I wonder if like an O-ring pops or something.
The old O-ring in the pop routine, yeah.
All right, women first.
Check it out, Sharon. You're going out there.
I want you to take this bubble gum and go seal that leak.
Yeah, they'll be like, now Sharon's out there. Let's talk business, Like, we've really got a problem over here,
Guys?
I mean, have you guys developed any guys? Have y'all developed any theories on like are you just gonna call it fake or what?
Well, yeah, a theory about what though? Like the theory what?
Call it how it is.
It's a Hollywood production.
No, I don't think any of us are even. I just think. Well, the thing that for the the opposition to it is just the I think that the profundity of all this is just to do with the idea that they control the way you see the world with shit like this. And that's, I think, the real whole premise of flat Earth, man. It's a contrary.
You're trying to do the same.
Oh, no doubt.
You're trying to control the way people see things. You're trying the same thing. So how does that make them bad news?
Right. No. It's a competition of philosophies.
Oh, what
that's what it is.
You always drag it down to this level, don't you?
Well, we already won.
What about the space too?
You're still here talking to. You're still here arguing with us. We beat the shit. Well, no, I'm just saying, I think, philosophically, flat Earth has won the debate years ago.
What? Seriously? You think that?
Oh, 100% Well, I say philosophically.
It was over in 2015, bro.
I mean, if you'd like to think that, that's fine. But the point is that that philosophically, yeah, flat Earth won. Flat Earth 1 is better and makes way more sense. As laughable as you think that sounds.
Even the final experiment wasn't final for any of the Glob.
Yeah, dude, you haven't done shit. You guys fucked up. I'll tell you what, if you guys wanted to win this fucking debate, what you would do, and I've been saying this for fucking ages, is just give up the idea that you're going to see curvature anywhere on Earth.
What predictions can you make with flat Earth, though?
No. The Babylonians were flat Earthers. Your predictions come from flat Earthers. Your mapping of the star system. Your mapping of the star system, whether you like it or not, it comes from Babylonians that were admittedly flat Earthers, and that's pursuant to Bowditch.
It came from Greece too.
And you can fucking cry about it all you want.
It doesn't matter.
We already won, bro. I don't even have to do this. You
don't have a point. So you just argue shit. That is absolute crap, mate. That's what I'm saying because I can't speak Greek. I don't know Greek philosophers about. Therefore, they're wrong. Dude, you're full of shit. Only you don't see it.
No, I see. Okay, the thing is that hold on real quick. The thing is that we understand your side. And we understand it, and we are all, I think, any of us, willing to accept it with so long as there is no reasonable doubt. The problem is there's a lot of reasonable doubt, and that's why it's like that's why people aren't convinced anyway. And then when people bring that up, you guys freak out, call everybody flat earthers, and throw a fucking tantrum. So we won already.
And what predictions have you made with flat Earth, or has anyone made?
Well, no, the Babylonians were predicting the fucking the eclipses and shit, for one. So these are old ideas that you guys have latched onto, and then try to convince us with arguments about acceleration how fucking wrong the people who gave you the ideas were.
Babylonians didn't predict flat eclipses, mate. That's bullshit. You're lying.
Yeah, no. Your issue's with the path of totality. Eat a dick.
The Babylonians did not eclipses. You're bullshitting.
No, go look it up. Go read Bowditch.
Because I never looked it up.
Okay, buddy.
I just looked it up then, and it's bullshit. And you know
You're talking.
No.
Your issue, if you want to deal with the Babylonians' issue about eclipses, and your only fucking argument is about the path of totality. That's the only, and the prediction of the path of totality. That's your only argument against the Babylonians. You go. Well, keep fucking looking.
Then, what you said. I just confirmed what you said to be bullshit. That's all I did.
Yeah, go. Well, dude, you know what?
You found out. You just got caught out.
No, I'm not. No, I'm literally giving you. No, I'm giving you the refined argument your academic mind just won't fucking accept.
How about the Greeks and the Antikythera mechanism?
It's not there. It's not true.
Boomer.
Right. Yeah,
Boomer, how about the Greeks and the Antikythera mechanism? Look that up.
Yeah, I have. I've actually studied the Antikythera. You know what I thought was fascinating? How they got 29.5 years for Saturn. They actually used a 2-to-1 gear ratio to knock it up to get 59 teeth to gear it back down. That is fucking astronomical genius. They are smart cookies, man. I love the Antikythera device.
What trips me out is I just had to triple check, and I know I've looked this up 1,000 times arguing with these knuckleheads, but just AI, you know what I mean? Did Babylonians predict eclipses? Yes. Babylonian astronomers were the first known people to predict solar and lunar eclipses. So where's your fucking information coming from, dude?
Yeah, and do you want to apologize?
No, I actually looked up and said...
You're the one that called him a liar, bro. You're the one that called him a liar.
Yo, motherfuckers, all you do lie. This is why we won. This is why you lost in 2016. Regardless of the shape of the Earth, if it will be true, you lost the debate because you guys suck at it.
ChatGPT, and you're the one who's having a fucking tanty right now.
Try harder, bro.
You check ChatGPT and said I'm lying.
Try harder, dude. I don't know what the fuck you check. I know Bowditch cites it, so I know from academia that... I know from navigation history.
Bro.
No. Just go look it up, dude.
See, dude, that's why you're not worth a discussion because you just.
Can anyone back me up right now? Can anyone back me up right now?
This guy's full of shit. He lied. He came on here and he said, "I looked it up, and I looked it up, and I proved that it's bullshit." Dude, you can say it's bullshit over and over and over again. It's not going to change the facts. So you lost. You guys lost. It's over. You guys lost a long time ago, by the way. Like 2015, you guys were done. Fork in you.
Wait, what happened in 2015? This debate's been going for centuries.
Amen. We just, you know what it is that what happened was there was a fucking a little lull in the mix because of the
No,
moon landing,
there was a
etc.
blip in YouTube where flat Earth content got temporarily promoted for for the views in 2015.
No,
So
people.
that won the whole thing.
No, hold on, no. That's hey, you know what? And that's a fair argument. And I think it got promoted because it wasn't as censored as it was, and people took interest to it. So it became a thing that the algorithm actually promoted because it wasn't being like censored like fucking the vid and shit. Like until and then when you got people online like Raskin in the Congress talking about we need to fucking censor flat Earth. So who's really like the intellectual champion? Some group of people that have the congressional fucking hearings to censor a topic on YouTube. You bitch motherfuckers. We still kicked your ass. And you got Congress over there apologizing for your fucking behavior online. Now, the point is that you fucking eat a dick. You're like the number one fucking suspect, bro. The fucking point is that fucking all I said in the beginning of this was that philosophically, I'm not even going scientifically because I grant that the celestial sphere and the globe is quite fascinating, and I've become much more lenient in my relationship to the globe, if to be so candid. And I just think that like the paradox is more what this is about than anything else. Like we can argue the numbers. I think once Dodovsky's book comes out and everyone realizes that dark polarity plays a matter in why the sun looks like it does, then I think fucking everyone will be satisfied.
What? Who's this guy?
Well, Matthew, you
Dodovsky.
You can't be surprised as to how popular it's been because it's a huge interest of yours. Like it's very popular in your personal life, so it would make sense why it was so blowing up in 2015, 16, 17, and then they did the censorship.
Yeah, the algorithms promoted sort of sensational content of all different sorts, and so yeah, that's kind of how it got a lot of popularity.
No, but people are into it. I'm trying to say that you are really, really into this. So can't you see why others are really into it as well? Like you've spent an enormous amount of your life focusing on this topic. So can't you see through your own interest that many, many, many others are also interested in this? Like it activates something very deep within people.
Yeah, I see that. I mean, it's an interesting topic.
Also, real quick, like for those people who talk about that nobody's been into this. Like this is just an old topic pre the fucking. That's why the moon landing is so crucial in this.
Yes,
is because that's what
101.
Well,
yeah,
and like well, just what's up?
I was just going to hear to confirm that you are right. They actually have evidence that they predicted the eclipses and they were on cuneiform tablets.
Yep. The issue is about the path of totality, which you can argue about with some of the more refined globers out here at times. But the point is that
an apology from them.
There's more than one.
I doubt it.
Cycle, right?
I'm not looking for it.
There's like what, a couple hundred different Saros cycles.
You know that it actually does predict the path of totality because these different calculations that they have calculated for your position on Earth. So whether the eclipse will happen in this location or that location, which is essentially the path of totality.
Yeah, man. You can make. Yep.
They know it's going to happen if you're at this degree of position in the relation to the sky. It's going to happen on this cycle. If you're in another position, it's going to happen on that cycle. That is the path of totality.
It's not the path of totality. It's the
great point.
It would be where it could come into contact with the sun.
It's where it's being observed, and the only time it can be observed is in the path of totality.
Right. That's where the eclipse is occurring. Like if you're on another position on Earth, at that same time, they don't predict the eclipse is happening, but you're not going to view it. It's not.
Yeah, you can see partial eclipses. It doesn't predict the actual path of totality. It predicts partial areas.
The point being is somebody said that it wasn't fucking being done. It wasn't being predicted. And it was as far as fucking our understanding of history is concerned. So
they're literally on cuneiform tablets.
Well, so the thing is that I think it's a matter of like, can we understand both sides and can we appreciate both sides? I've really become to believe that is the move. That's what this is about. Our ancestry did better when we had both of these options cosmologically. And cosmology affects your philosophy. And a flat earth is a religious, sentimental cosmology.
Well, if I can quote you, Issa, you said that flat Earth has one, quote unquote. Can you tell me what you mean by that?
Has one in the sense that, honestly, I almost look at it like what's happened is like an anime movie where the sword is like cut through the enemy, but it takes like a fucking half an hour for the fucking enemy to slit into two. You know what I mean? It's this big dramatic 15 minutes of like the whole thing falling apart. That's what the globe is doing. And I don't think it's a finality because I think the globe and the flat earth work in tandem. Like you can't, I really believe that it's in a certain sense like flat earth, or rather the globe, or either whatever paradigm you're starting from, even, I'll grant you this, is that whatever paradigm you're starting from, it's like Santa Claus. And like you have to like once you revise and look at Santa Claus as you get older, you realize that might not be fucking true. And the other option, which as horrifying as it might be to the opposite argument, may be true. And you kind of come into this dance, but an intellectual dance between these two Santa Clauses that you can't necessarily verify without a third party. And you have to make a philosophical choice because there is no confirmation. But the problem is most people are like, they treat an unknown problem like it's the boogeyman. Like if you hear something go bump in the night, you have to try to identify it. Oh, that was just a cat. Oh, that, like, you know what I mean? We have to try to pigeonhole it what it is. And so both sides are in this struggle to call out what they cannot confirm to be the truth. And this is the philosophical value of this paradox. And we benefit from this as mankind, in my opinion. As soon as we get locked into one cosmology, I think it carterizes some kind of capability within mankind. And this is like a limiting capacity. This is limiting. So to try to pigeonhole us into a fucking cosmology is very limiting for us because it takes away the mystique of the whole thing. Never before until the moon landing did you have a group of people that could stand upon the shoulders of some kind of achievement and become tyrants about the subject. Whereas before the moon landing, people didn't know. So at the end of the conversation, the argument or whatever, there was no real like we still had to be friends. There was no like, I look at you as though you've departed from reality and you're fucking insane. Do you know what I mean? Because that's how flat earthers look at globers and globers look at flat earthers. Right? And we're all using the same set of evidence for our proofs. It's fucking nuts.
What evidence are you referring to, actually?
Every single piece of your evidence to confirm the globe is a flat earth evidence.
So like sunsets?
Sunsets, you pick one. Any one of them. It's a
mountains that are okay, I got one for you. Mountains that are in the distance, twice as far away, that are twice as high, that are not lined up. How is that evidence for a flat earth? Just be honest with me.
Because you're dealing with optics. And so it's easily explained away. And this is why I said earlier, if the globe wanted to win this debate, hold on.
How is it explained about optics?
Because light is fucking funny at a distance. And when it travels through mediums and shit.
You're not making any sense right now.
Am I not? Really?
Seriously,
Zanick, remember your whole light bends towards the
What are you talking about?
You know your whole thing of your light bends to the denser medium? Well, there you go. Things are going to drop.
In fact, Zanick, you know I've been arguing this forever. I think that every one of you Globers that has come out here, you literally made the fucking holy mountain out of the molehill of sunsets.
I didn't even mention it. I didn't mention
No, you're alluding to it, and I know. No.
I'm not going to mention it.
And your next argument is like obstruction or some bullshit. And like my point is.
Well, yeah. So you got these you got these windmills.
I don't even want to do it, bro.
Hold on. I'll let you talk. Let me just finish the sentence.
Sure.
So you got those windmills that are friggin' 200, 300 feet tall, yet all you see is a tip or the annulus of the impeller or the propeller, and angularly it shouldn't be there in your field of view. But
no.
Hold on, real quick. Go back to what I first said about the mountains that are twice as tall, twice as far away. Gio alluded to light bending, and I would agree, light can bend. But if it bends down to the denser medium, that means the light bends down. That means you see things looming up.
You know the problem with that?
Hold on, I'm almost done. If you got it backward, it can be confusing. So explain to me how it's possible that the denser medium is actually upward, not downward.
Well, explain to me how it would be possible at that scale that during parallel sailing, they recognize that you can navigate 600 nautical miles as flat.
What do you mean?
You cannot reconcile this, dude. And so the point is that no, hold on.
You're answering it for me. You're not being
well, because I'm destroying your argument.
Honest
No. Listen. I'm explaining why what you said is fucking stupid. Because the point and inconsistent with the globe. But the problem is that's why you guys lost is when you did. Because this inconsistency that you just apologize for is so pathetic. You make flat earthers. In fact, it makes it so.
All you're doing is saying words. You're not explaining yourself.
Okay, all right. Let me explain that. The scale that you're talking about, where there would be curvature at that distance, right? If the Earth were that fucking rotund, okay. You couldn't have it where in parallel sailing or in sailing, you don't need to correct for any curvature or do any kind of fucking No, it's not.
It is.
It's not.
So appeal to scale.
This is why you lost. This is why
appeal to scale fallacy. You're not explaining why
keep burying yourself right now.
I'm not burying anything. You're just calling
you fucking are. You don't know it though. That's what's crazy.
I do know it. You think I've just fell off the turnip truck here in this?
What are you just fucking trolling for the globe right now? Because you're making the globe.
Well, I have physics knowledge.
I have physics. Your bravado also pisses.
You can do yourself. You can actually do these calculations. You can tell me what you think is happening. So I have a large scale. It could be 200 miles. It could be 50 miles or 100 miles. I don't care what distance you use. You always will see these large objects that are known to be a certain height above sea level.
Try harder,
that
bro.
Are a certain distance away using simple trigonometry. They should align, yet they don't. And Gio, again, he alluded to why this happens, and it's true. Light does bend down toward the denser medium, or up if the denser medium's upward.
Right? Why are you trying to fucking put your finger on something that can't be fucking placed down, dude? Like, this is the point about the light issue. That's why it's so. This is why I said to you before. It's like, and I've been saying for fucking since forever. Was fucking the idea that if you just let the horizon be and the curvature of the Earth. If you guys had just said, yeah, dude, there's no fucking way you would experience the curvature. If you guys just poo-pooed the very first argument and like you gotta, it's Bill Nye's number 2 or whatever with boats going over the curve of the Earth. But when you guys let that one go, the globe has a chance. Until then, the Earth's fucking probably flat because you guys fucking put your foot in your mouth.
Well, I heard it's the way you see things, or it becomes this point like the Rayleigh.
Yeah, people.
Let me
flat Earth is
I let you talk. Let me
I just want to say this though, Zanick, let me say this. And then you can go. Hold on real quick. Just flat Earth is a return to trusting your senses. That's it.
Okay. Well, your senses, we know by easy tests in science, in medicine, in human physiology, we know we cannot detect certain G forces that are not great enough to be detected.
Right, and Kim Jong-un made that haircut. You know what I'm saying, dog? I really sure.
What about my haircut?
No, I'm saying I think like fucking Globers who think like that are North Koreans, bro. I think like you basically are like, no. Kim Jong Un made that haircut. He actually ascended the throne and got. I just think it's a fucking propaganda piece, dude. Like I just don't think that like.
I can't remember what I was even talking about because you got to let me finish the thought here. So, what were we talking about? I was bringing up a point you made, which
you got me going on about North Korea. I swear to God, I feel like I'm talking about North Korea.
Where did that come from? Okay, listen, just hear me out. So we have these 300-foot tall objects. Oh yeah, because everyone says they're kind of disintegrating or evaporating into the line of delineation between the ground and the sky because of Rayleigh criterion. So without really understanding what that actually means, that may be true, or there may be a part of it is possibly a little bit true, but it doesn't account for the fact that the impeller is not above the surface at the right angle for the distances it is away and how tall it is. Well, it doesn't matter what you can see near the surface. I'm talking about what's left over, like the ship.
I get it. Are you kind of getting? I mean, like aside from like because I think your best argument I've heard you make, and I know you're a diehard Glober, is that argument you were making the other night about being in an airplane, and that the fact that the horizon appears level at like whatever amount of degrees below the horizon consistently, and your explanation for why that could be possible on a globe. Like I appreciate that, but this arguing about the idea of obstruction in these panels and something like so not far away is like I just think and it only promotes flat Earth. But but I appreciate like the other argument that you had about the fucking like because even then you admit that there is some like flatness to it. And all I'm trying to say is, and I think if the globe just conceded that there is a flatness, which it does, right? It says, I mean, even in navigation, they tell you to treat the Earth as flat, and then they apologize for 15 minutes about how it's not a flat Earth. But like at the same time. And that's all because think about this, Zanick. Think about the effect we had on the world. Every navigation video that you'll ever watch after 2015 has to fucking apologize for flat Earth after telling you that you have to treat the Earth as flat in order to conduct the procedure that you're about to learn how to do. That's weird, dude.
Well,
just saying.
I guess the answer that you might think is a cop out. I mean, I like talking to you about this. It's kind of fun. But I get what you're saying because. Like on local levels, and Gio brings it up too in a lot of our discussions, that surveyors and things treat this 100 square mile area as flat. Nothing really is going to be a problem if it is curved because we're doing it over such a small distance or small area. It's 10 miles in every direction, right?
Right.
So I get that, but doesn't mean it's flat. It means that.
Hold on, but Zanick,
this is the cop out that all flat or globe earthers will use.
No, you guys, no, you're too into Hold
on, I'm giving you a bonus. Let me finish it. So the globers will say, hey, but the curvature is so small, you just can't see it, right? They're all going to say that, and it is the truth, though. And as far as feeling yourself spinning, motion through the universe, that's all elementary. This is like fifth grade.
Right, but okay, how about this though?
You don't have the curve. You don't have the change in direction, which generates the G forces, which you can feel because it's 0.05 or 0.05% of your weight is the centrifugal force of the spin. So that's nothing vestibular systems can be able to detect. And the things we are actually seeing. There is the evidence of curvature are the horizon drop at below level. And I was conceding that. Maybe we just can't see that far. Maybe I was arguing with Brenda about that, right?
So, well, I think dude, the thing is this: is that every part of the globe's answers or quote unquote proofs for itself are completely fucking like totally dismissible. You know what I mean? Like, because it's like, oh yeah, no, it's like 0.6 fucking of an inch. That's what you don't understand, and it's not that much, and you just wouldn't fucking perceive it. And it's like a sales pitch of like the worst kind because it's like this. Okay. It's this cosmological fucking
check this picture out there.
It's like it becomes religious, dude. It's like, no, you don't understand. Like, you don't see it because you don't see. How about this, dude? Literally, think about this, bro. We went through fucking 2 years where people literally were like, one of the symptoms is that you don't have any symptoms, bro. Like, this is where the globe's at right now, dude. Is that it literally is like, no.
Like
you
that
wouldn't
sales
experience
pitch line because it's like they're selling you the flat Earth, but they're trying not to tell you that it's a lemon that they're selling you, and they're hyping it up.
That's funny. You said one of the symptoms of a globe Earth is that you don't actually observe or measure any curvature.
Exactly. That's how we. And even better yet, it's like that's how we know it's a globe.
No, that's not true. But
it is so fucking true, and that's why you lost. Back when you lost, and it is what it is.
Before the picture, I don't want to do like spamming. So before the picture gets too far away, I said, just go check it and just explain to me what you're seeing in that picture. We've seen it a million times, but I understand the way our eyes see, and it's close to the horizon. You can't delineate between or discern between one object and the horizon because they're close together, and it's a limit of our vision and Rayleigh criterion, all that stuff. Right? You tell me what you see in that picture when you see that windmill. Can you see the windmill picture? I mean, it's hard to get people.
Yeah. I got it. Dude, I tell you what, I just don't see. I don't see Earth's fucking curving.
Wait. You can't see it.
I don't see obstruction.
Why is that impeller? Why is that propeller right on the water? I mean, probably like in actuality, maybe 10 or 15 feet above the water. Where's the rest of the structure? Where did it go?
Dude, I have video in my own. I have my own footage of water doing this. In fact, you know what, Zanick? I think I've shown you, right? And I've put it in here. I think I brought it up one time.
Well,
it's like
picture.
I have. Hold on, Zanick. I have literal footage of a boat going behind a mirage of like water. I have the footage.
I've seen a million times too.
You've seen that, right? You've seen my footage from my video, right?
So address this picture.
This is exactly
You and
This
me,
is
like
after
two
the
intelligent adults talking about this picture, and I don't care how bad your answer is by my judgment. I just want you. I want to hear it from you. I want to talk about that.
I'm telling you, I have. No. I have evidence of this phenomena
what do you think's happening here?
I'll show you. Do you want me to go? Should I go get the footage?
I want the answer. I don't want to be
I'll go
seen
get the footage for
anything.
you. No. I'll go get the footage for you because.
God dang it, man! You're
I like you. I like you, Zanick, and that's why I'm going to go.
I know, and I like you too, and I want to hear your answer.
Right. Well, my answer is the evidence that I have.
No. That's not the answer.
Oh yeah, it is. It's the fucking answer to this stupid shit.
That's not an answer. It's not circular reasoning.
I want to know. One of the fucking symptoms is you have no symptoms, bro. That's what it sounds like.
Why is
your side is the side of circular everything. You're circular everything, bro.
Stop a second. I want to hear, even if it's like super creative and I can be proud of like you, like, wow, I never thought someone could come up with that. I want to hear your answers. I can care less whether it's right or wrong.
The shape of the earth is determined on your answer. Come on, brother.
No, I just want to know why he thinks that annulus of the propeller is right on the water, maybe 10
I'm going to show you, bro.
No, I don't want to be shown. I want you to tell me.
No, why?
Because use your words, Issa. We want to hear your words.
Okay. Because of optical effects regarding heat, water, and the medium of light.
Okay, what would be happening in that?
Now, I got to find exactly where. I forget exactly where this is in this footage, but I know it's like.
It doesn't matter.
Hold on. Issa, while you find the timestamp, can I just get 10 seconds, Zanick, real quick? I'm not going to go on a long thing, although I could.
No, I can't go with the heavy hitters. I'm going with.
No, I'm just going to say briefly. I'm just going to post this. Even if you ignore the atmospheric magnification label on there, those pictures are the same location, same elevation, but just different days. So obviously, the two oil rigs are the same distance on these days because it's from the same position. On the left, the legs are cut off, and the one on the right is lower. On the right, the legs are not cut off, and they're at equal height. So whatever the reason. Hold on.
Yours. Okay.
Whatever the reason is that that's happening, the one on the left, somebody might say, oh, look, there's the curve, it's the globe. But then the one on the right, it's gone. So maybe on the globe, you would say, oh, it's a refracted horizon. Whatever it is, it ain't Earth curve. That's not a physical, solid ball that you're looking over. It's 100% not that. Even with the globe explanation, you got to say, oh, it's a refracted horizon. Bottom line is that this happens. So just like with your windmills, it's the same type of effect. It happens. Now, I could go on a whole explanation. It seems like a lot of people want to get in. I'm not going to do a whole long thing. But, it is occurring. And it's not isolated to being Earth curve for the reasons I just said. But yeah, go ahead.
Hey, yo, 251 in my video.
I'm bringing your boss in, huh?
251. Well, Gio's real good at it. He's the flatter. Dude, he's the flatter's boss right now. He holds it down.
He's a mob boss.
He's holding it down, bro. He's holding it down.
No, Gio, before you go, Gio, can I respond to you on those? Because you had left and right. And I wasn't following. You said the legs are cut off on the left picture, right? It's down low, right? And it's hidden. The legs are hidden for some reason. And then the right, and we're seeing it. I agree with you. We're seeing it. But the one on the right shows the entire structure below it, the legs, and it's also roof lines are equal. And we've had this discussion 100 times. So how is that? That can't be possible. If that's the correct situation, how could it be at the same height level of the buildings on top of the structure, the oil structure, if perspective dictates that it should go down as it goes farther away? It shouldn't be near the same level since it's twice as far away.
Sinking refraction.
Okay.
Zanick, can you check out that video 251? I tagged you in it. And you can see the boat go behind the wall of water. That if you didn't have the footage, you would tell me that boat is behind the Earth's curvature.
No, because I'm aware of it.
This is an example of how that phenomena. This is the example of that phenomena happening.
Yeah, but you know what's funny about that, and kind of telling about that, is that the angular position at the top of the sail that still stays in the right spot. Yet you can't see the boat below it.
That's the point.
When I say right spot, I mean it could be due to curvature because it's lower than it should be. But that angular change, hold on, just because you don't see the boat doesn't mean the sail is affected by that.
No, dude, Zanick, the video I'm showing you literally.
It's not hidden by. It's not hidden by. I'm backing up what you said. It's not hidden by Earth curve. You're right. It's hidden by the mirage. But yet the sail is in an angular position which is lower than it should be based on its distance. That's the point.
No, you're just making shit up now.
I'm not making it up. This is the truth.
No, because A, it's going through a medium, and B, the point is the point of the video is that no. Let me just explain now. Is that you can see the boat, and then the mirage literally overtakes the boat, and you can no longer see the actual boat. You can just see the sail. So, and then, this is the type of footage after the fact, after the boat has been covered by the water, that you guys would fucking drum up and say is Earth's curvature. And you've done this repeatedly, and this is why I'm just telling you guys, this is why nobody buys that argument. And for the globe's sake, you guys should just give up the whole you would experience Earth curvature instead of dying on, no, it's 0.18 of an inch at that distance.
Is this Chesapeake Bay? Where is this? No, this is Chicago.
I think it's
by the way, I'm playing it on the screen share as well. Anyone wants to check it out? You said 251?
Yeah, 251. Let me check it. Let me join.
I'll replay it a few times. I'm sharing it on the live stream too. So, unless anyone wants to see it.
So you can see the boat. You can see the boat, and you literally see it go behind the wall of water.
What are we looking at now? Looking at live stream now from Geo?
Yeah.
Screen share. Okay. Okay, show me. Oh, the music.
Here, I'll go back. Oh wait, does it have audio? I
just turned it off.
mute it.
Yeah, it's got some music playing in there. But the way that it cuts off the front of the boat is it got what I think is what so many of us, what they tell us to be curvature.
You know, the funny thing is this can be demonstrated on a small scale that would not match up with any type of curvature measurements, right? Like you can do it on a small scale over water.
You're leaving something that I brought up earlier out by not even looking at what's hidden. Now we can look at the sails. The sail, like when the sail is in front of that house, you know how tall that house is, you know how far the house is away, you know how tall that boat is and how tall the sail is. The boat is missing due to the mirage, not due to earth curve, but why is the sail not in the right position in your field of view?
Atmospheric conditions.
Now that one over there, it's being shown now, that looks like that could be earth curve. I'm sorry, my friends. Especially since there's so much missing of that. Is that Chesapeake Bay? That is, isn't it? No.
No, that's a Verrazano. That's New York.
Oh, New York, okay.
And even that one, that's not even 14 miles right there. Guaranteed.
No, it's not. Well, the one by the bridge was like 8.9 miles. Like Verrazano was 8.9 miles from where I was.
So what would the expected curvature be over 8 miles?
Right. That's what I was tripped out by because it's like it's supposed to be a couple of. Well, let's look it up. What is it?
Because the observations I do over 14, like it doesn't match that.
Is that the Brooklyn Bridge? No, what is that?
Verrazano.
Verrazano, okay.
So if this is 8 miles there, why are you missing like 15 feet of that boat?
And those buildings you can see deep in the tower are over in Jersey.
Well, you're not because we have.
Forgive me, might not be Jersey. It's trying to
So
think
the
what
thing
that
about
was.
that, right, is that's a crispy, clear horizon line, which the Globers say, oh, little refraction. If it's a crispy, clear horizon line, right, that wall of water is a crispy, clear line, then there's very little refraction going on. Then why are we missing so much of that boat over 8 miles?
So much. That hull is no more than 6. That one we're looking at right now is like that's a 6 foot.
This is a different observation. Different observation. You don't have the crispy, clear horizon. Yeah.
This is that effect happening.
We're using a lot of it in the miraging for sure.
I just think like when it comes to distance and like trying to prove curvature, it's a moot point. There is nothing that's going to really prove people unless they're convinced.
When you zoom out like that, it makes it look like it's a lot farther than it is. That's not that far away. You're right. I mean, I don't know what the distance is, but because you can't really tell.
But on this one here, watch this wall of water that you're looking at. Look at how clear that horizon line is, and how much of that boat is missing.
Which is a small sailboat. That's probably a 3 foot. That's probably a 3 or 4 foot hull. That's it.
No. That's a big boat. Those are big boats, man.
If somebody's,
I mean, that's not a big boat, but that's not
a big boat. The other boat's a little boat with a single sail. Those are usually little boats.
Right, but not like one of them little, not a practice one or something.
No, not like the one that's in this. The one that's not this yacht here. That one, like the one just went by here. The sail is actually bound up, and it's got the jib sail still up.
From water to the top of that, like that smaller boat right there, you're looking at least 6 feet. And then when you go back to this one,
that's probably 7-8 miles away, right?
7-8 miles away, you're looking back at this one, you're missing at least 10 feet on that boat.
No.
Yeah, the entire hull and some above that.
It's above the bottom of the sails. I guarantee you those sails are at least 8 feet above the water line.
Okay, 8 feet then.
I don't know who this chick is.
Okay. That's another, yeah. So it's not so far off of. We don't know how far it is. I mean, you keep throwing these pictures, and that one looks like a pretty clear water line. Say that is Earth curvature because I don't see a lot of miraging going on there. We don't know how far it is, so we really can't argue that much about it.
The clearer that water line is, the most of the time, you're having extreme sinking refraction in those instances.
Sinking refraction means light bending up. That doesn't usually happen.
No, it doesn't.
Yes, it does.
So you disagree with subject matter expert?
Looming refraction means the light's bending down. Sinking refraction means the light's bending up.
Incorrect. Can you give me a citation on that?
I'm the citation on that. Come on.
Exactly, because when I reference Andrew Thomas Young, that's not the case.
Yes, it is the case. Sinking happens when light bends up. Looming happens when light bends down. Andrew Thomas Young, out of his own words, says this.
I have his documentation.
Read through
it many times.
I'm not lying to you. I'm not even making things up. I'm not wrong either.
You're gonna have to cite that one, Zanick. It's not
really
sinking refraction.
That's not the case because the closest thing to standard atmospheric refraction is sinking refraction.
Hey, Gio, if I get bored of this little clip, go to 41 seconds. It's a cool little clip.
All right. I'll put it back to 41.
But yeah, I think like that's pretty much example of what I've been talking, like why it just doesn't work out, man.
That P1000?
I mean, dude, if that cutoff point acted like an actual physical blockage, it would be much stronger for a concept of a globe. But it just doesn't function that way. It changes, it alters. So then that's why you'd have to say, oh, it's a refracted horizon anyway, so it's not even the curvature at that point. And then some will say, well, it's the effect of curvature. Well, what does that mean? It's the effect of it, but it doesn't actually physically block things. Sometimes it's just, it does, and sometimes it doesn't. And then somehow, like you haven't really isolated that there's any curve in there, other than just the optical effect we can replicate. When you have a distance of how far you see on the ground, the rest is sky, and you have a boat that's beyond the how far you can see. Like that shot right there, that water, there's a limit. Like those waves you see right at the horizon line, you could go out there and touch that wave. You know, you could go out there and be right there at that wave. And so let's say that's 3 miles, for example. And if you go past that, you go 3.5 miles, 4 miles, 5 miles, it's going to visually obscure because the horizon is the meeting place of the ground and the sky over a planar surface, and you're going beyond that last wave. That's exactly what would be expected to occur over a planar surface, which can be replicated on small scale as well.
But the crispy horizon.
I mean, I got some quotes I'm searching. It says, while standard atmospheric refraction generally bends light downward, causing objects to appear higher. That's the first thing that comes up when you search for it. And I'm sure that's in Andrew Thomas Young's writings if you read it correctly. Because I know this to be true, because I know how light bends. I know how the Snell's law works. And I know the differential version of Snell's law. It's not like something I'm making up. It's something I'm pretty familiar with.
You know the quantum version, which is the one that matters.
The quantum version? The quantum version, Don?
Yeah, light obviously doesn't. Yeah, light obviously doesn't have a quantum path, right, Zanick? Fucking clown.
I don't think you can look at in a context of light. We're not talking about it in the quantum realm. We're talking about light bending due to Snell's law, which everyone should agree with because you can prove that it works yourself.
Probabilistic path. It's going to take like the average of all.
It's not a no, this is not a relativistic discussion. We're not talking about a probabilistic path. It always will move. It always will move in a direction of the denser medium.
With standard atmospheric refraction, is light bending up or down?
Light is bending down.
Okay, and sinking refraction, that quote you just said, is it bending up or down?
Bending up.
Read your quote again.
It's bending. I told you the answer.
You said bending down.
It's bending upward. The light's bending upward.
Read your quote again.
Like from Google, a Google search, which is usually wrong, by the way.
What you previously said is in sinking refraction.
I read it. I read it to you. Let me hear what it says. It says light bends. Oh, what did I find it? No, I want to make sure I read it. I said, for rod sinking. Don't laugh. Don't be a jerk. Sinking refraction versus looming. While standard atmospheric refraction generally bends light downward, causing objects to appear higher. Okay, that's what it says. That's what I'm saying. I haven't said anything other than that.
Trying to help me. Trying to help you. He thought he was like.
You quoted sinking refraction and it bending down.
I said no. I didn't say. I said sinking refraction would be the opposite of that. Looming. So when things appear higher, that's called looming. Would you not agree? Yes or no?
I disagree with all of your.
No. How come I never can have a question answered by a yes or no when it says you always give me some other thing that's not related? Do you agree when something is loomed up that light it's caused by light bending down?
Zanick, all I did.
You can't answer
it. I wanted you to reread your quote about sinking refraction. When
I didn't say about sinking refraction. I said well, my quote was
light bending down.
Your videos.
My quote was and I read it. While standard atmospheric refraction generally bends light downward, causing objects to appear higher. Do you not agree with that statement?
I'm wanting you to reread.
You can't answer. You don't want to communicate at an intelligent level. I don't understand.
But we're not talking about what.
Sinking
like I said,
is the opposite. Sinking is now. This is me talking. Sinking is the opposite.
You won't
sinking means the light is bending upward. Light bending upward causes things to sink. So that's me talking. That's not my position. Don't misrepresent it.
That's false.
Don't misrepresent it. Please
what causes sinking refraction? Okay, what's the light doing? When
it's bending upward. Bending upward.
Downward. Towards the denser what? Towards the denser.
Wrong, Rigger. You're wrong, Rigger. You're wrong.
Okay, just saying that.
No, it's not.
Over and over.
Literally, Zanick read the quote and he thought he was going to have a gotcha about sinking refraction, and he said that the light was bending down for sinking refraction.
No, I didn't. I read it. I know I said because I read it right off the fucking page here. While standard atmospheric refraction generally, stop talking. I'll say it last time. Last time, while standard atmospheric refraction generally bends light downward, causing objects to appear higher. That's what I said initially, and I'm saying it again. And that is looming. That's called looming. Sinking is light bending upward. Now, don't misrepresent what I said.
No,
that's your citation.
That's not what he says.
But you read
the denser medium or the denser air down.
Light bends to
or
the
you're going to say
medium.
it's denser above.
It never is
denser
denser
throw away
above.
how gravity affects
It's
air.
never a denser above.
Right, exactly. So
if
it's
you guys
bending
actually
down
think that-
because it goes towards the denser medium. This is
my
basic
God.
Snell's
Oh
law.
my God.
Why are you messing this up?
So lost.
Sometimes it's denser above.
Well, it very rarely.
Zanuck is right. Zanuck is right, though. He's staying consistent.
So full of it.
They talk about a temperature inversion. That just means it bends less down, but it's still bending down. Now, there are extreme cases.
Inverted would be
hold
up.
on. Let me just finish the thought. There are some situations where the objects are like above level, so it has to be bending upward. It has to be that extreme of a temperature inversion where it actually is slightly denser upward for a very short, narrow band. Now, that does happen, but very rarely.
Yeah, the inversion would cause the light to go up because we already know
Or
the light
less
goes
down.
towards the
Or
denser
less
medium.
down in most cases.
The light goes towards the denser medium, right?
Look, we have things that are
it
looming
travels in
upward.
that direction.
We all know they loom upward because the light's bending down. Sometimes
so
there's
the
a
light
temperature.
goes.
Can I just finish the thought? Is it possible?
No, you can't
So-
answer a question. I don't want
No,
to hear you
I'm
talk
making-
about
I'm answering the
minute and a
question.
half.
Stop clipping,
Yes.
Ruger.
I'm answering the question. So generally light bends down. When you have a temperature inversion, it means it bends down a little less. That's what it means. Now there are some extreme cases where light can bend slightly upward because we have things that should be below level that are above level in extreme cases. So it does have that would be the hold on.
Can you let me address
that
that
would be
at least
God
one
dang it.
thing before
Come
you
on.
carry on? Yeah, so inverted does not mean slightly less.
Yes, it
That's just
does
you being
actually.
wrong about the
No,
word
that
in
is
general.
not wrong. That is exactly what it means. When you have a temperature inversion, like over Santa Barbara with the oil rigs, that's the reason we have this looming, because instead of light bending, it's still bending downward, it's just not bending downward as much. So you're seeing more of this object than would normally be seen because it's loomed it up.
So what
That's
happens?
why you see
What
it.
happens to the
And
to
if
the
it was
the
not as
gradient?
extreme, it'd be even higher.
Right. So what happens to the gradient? It gets inverted.
No, that's not
so
what that
happens
means.
to the light? If you invert the density layers,
If
the
it could
light's
be-
going to go towards the denser medium.
Yes,
Right.
if it-
so if you put density up top, the
I'm not
light's going to
talking
go
about
up
that.
top. If you put density down low, the light's going to go down low. So you're getting this all backwards, dude.
I'm not getting
All
it
of it.
backward.
100%.
Not at all. You are getting it backward. We have extreme cases of refraction where actually the density becomes a little greater above at a very narrow band. So that would be sinking refraction. That make things drop down. Yet we see things higher than they should be, which means you have it backward. It makes your problem worse. You're just not getting it. You're thinking I got it backward. I don't. You have it backward.
You're not explaining it properly.
I am. It's
Yeah, you said
counterintuitive because
inversion.
you're saying
You said when it
people have a
inverts,
hard
it
time
just goes
understanding
slightly
light bending
less down.
down
That
looms
was your
things
answer
up.
to what inversion
Okay,
means.
the
It goes
operative
slightly
the
less
operative
down,
statement
when
the
there's
operative
just the
statement is
opposite of what inversion is. Inversion is actually, if it was going down and you invert it, it would go up.
That's
and you
not
think
what it means,
it's
though.
less down. That's just fundamental misunderstanding
No,
of
that
inversion.
is
Just
the actual definition of temperature inversion. Go look up temperature inversion for refraction, and it will tell you this.
I'll walk you through it again, right? So you put the densest layer on the bottom, less dense on top. Then you invert that. What does that mean?
Temperature inversion, not density inversion.
Do the same thing with temperature.
No,
because temperature is going to affect the density.
It does,
What
but
are you even trying
it
to say?
doesn't reverse the density.
So you don't want to
profile.
answer any of it.
You're being so pig-headed. Listen to me very carefully. You have a temperature that is normally a gradient that goes down as you go higher. It only goes down as you go higher. But if you have very cold water near the surface of the water will absorb heat from the air, making the temperature lower. Hold on.
I don't know why you keep trying to explain.
I mean, this is a learning moment, Rigger, and you're not listening.
Okay, what do you think a
This is a
superior
learning
mirage
moment
is?
for you, and you do not want to learn.
You're not teaching me anything. I know you're wrong.
Because I know you
right?
think you know something.
What
You're
is
right,
a
you can't be
superior
taught.
mirage?
You're being pig-headed.
Explain to the class what a superior mirage is. In which ways?
No,
do I go?
I'm not going to take a non sequitur here.
Because you can't. No, it's not non
No, I
sequitur.
can. I don't want to confuse you.
That's inverted. Superior mirage is literally inverted. It is the actual subject we're talking about. How do you not know this?
Okay. I hate to go down this track because it's going to get down a whole other rat hole of information that you can't absorb because you can't even absorb the basics. The superior mirage is related to internal reflections. You're getting reflections of this image that's reflecting upward on the atmosphere as well. But it's much more complicated than what we're talking about. What we're talking about is super simple. Super simple. Temperature inversion, not the image inversion and not the density inversion. It just means that the temperature is hold on. You got you'll never learn because when you should be listening, you're talking.
Right. So I just want to clarify that right there, that temperature inversion is what creates a superior mirage.
No.
So which way is the light bending in the superior mirage?
There's a combination of refraction
Upward
and
is the
reflection.
answer.
There's an internal reflection causing a lot of that. For example, when you
so
see
you
things on a road that has the steamy look on the road and you see reflection of a car, that is
which way is
that
the
is
light
an
going?
inferior hold on. That is an inferior mirage. Doesn't mean that there's any refraction going on. It means there's a reflection going on. There's a very fine line between reflection and okay.
Dude, if you guys are gonna do this, could you at least like go one at a time and maybe chill it down a little? Just try not to monologues. I think what happens is one guy goes really long, the other guy just is like, F this, I just want to clip him. Can you just go shorter back and forth if you're gonna do this? Because it's kind of hard to follow right now.
I agree. Let me go first real quick. Or unless you want to go first, it's up to you.
Yeah, I'll go first. Can you answer a simple question of superior mirage? Which way is the light bending? Up or down?
I don't want to answer that because we're getting off the topic.
No, it's not. It's literally temper
It's
inversion.
a combination of things.
The superior mirage to begin with.
It's a combination of things. The superior mirage is not only caused by the light bending; it's also caused by reflection, internal reflection. So I don't want to go down that path. Why can't we stay on what's simple? Light bending, an inferior, excuse me,
because this is the fundamental core.
No, it's
this
not.
This is the fundamental
it's
disagreement, core misunderstanding you have.
No, I do not have a misunderstanding. It's you that has a misunderstanding. I'll tell you why. Simply, the temperature inversion only means the temperature, instead of going down as you go up, it goes up as you go up. Because it's colder at the bottom, because it's near the cold water, so it takes heat out of the air that's right above it. That is called the temperature inversion. How much of it happens depends on, will determine how much that gradient changes. That is true.
Right,
but generally, hold on, let me finish. We're going to finish up with each other, and then we can go back and forth. So we have a temperature inversion, which means now the light will be bending less down than normal. Now bending down looms things up, but it doesn't move. It looms things up when light bends down. Things loom up. I already explained that, and I read you a citate or a definition. You're not accepting it. I get that. But if light bends upward, you'll have. If light can bend upward,
you got to let somebody else address one thing you're saying. This is endless dribble from you. Okay. You said the temperature inversion changes the gradient. It inverts it.
No, it changes the temperature gradient.
Yeah, the temperature. Right. You're saying that's what causes the gradient to flip. Okay. If I take the gradient and I stabilize it in a certain structure, dude, I let you go for how long, dude? Come on.
Can you guys just do 30 seconds back and forth? Like,
yeah, go ahead. I just want to. He said saying things I'm not saying.
All right, so we have a gradient. We stack the layers, right? We stack the gradient, right, in a direction. We send light through it. The light is going to behave a particular way. Okay. When we invert that, meaning we flip it, right? We reverse it. We send the light through. It's going to go the opposite way.
That's not what I'm talking about.
So you are telling me I am okay. So you're going to tell me light bends when you look over the horizon, but when the conditions are inverted, light just bends less. That's incoherent.
No,
the
it's
light
not.
would actually invert.
Can I try to explain?
Because the gradient is traveling through.
Let me steel man your. Let me. It might help if I steel man.
I almost got through with it. I almost got through.
I thought you were done. Go ahead. My turn.
You clicked the whole end of it.
So you said when we invert that gradient, light will then bend upward, and I agree with you. But you said also, when I have a temperature inversion, that the gradient doesn't flip, it's just less down than it was before. You're saying it's incoherent. It's not incoherent. It makes perfect sense, and it's accurately describing what happens when you have a temperature inversion. You're not understanding that temperature inversion does not mean gradient flip. That's your problem, and you have to rectify that before we can have this conversation make any sense to anybody.
You change the density through the temperature. What are you talking about? The gradient is changed due to the temperature.
Yes, it doesn't mean it flips.
Okay, so now you have an inverted gradient.
No, I just said it doesn't mean it flips.
You inverted the gradient.
No, I didn't. See, this is where you keep on making the same mistake over and over again. No, I'm not saying you. Listen, there's a temperature gradient and there's a density gradient. The temperature gradient flips. The density gradient didn't flip. Why? Because the temperature gradient wasn't dramatic enough to make the atmospheric gradient.
Oh well, now you're not talking about. Now you're not talking about.
I know you're not listening because you just clipped me right there and you didn't hear it. Because I gave you the answer you're looking for and you didn't hear it.
I know what you're saying.
I slowed down. I said it very articulately.
And
you're just talking over me now. I said, there's two things you said. I steel man you. You said, if you have the density gradient invert, light will bend upward, and I totally agree with you. So there's a steel man. But I didn't say that the temperature inversion creates a flip of the density gradient. It affects it, so it's less, it bends downward less, not as much. You said that was incoherent. Your words. And
okay,
then guess what? You don't have an inverted refraction. The same exact point last time, you're interrupting me again. You can't let me finish.
Don't stop, guys.
It's impossible.
You don't stop talking. You don't let me address anything.
It was a simple fucking statement that steel man your position and then gave you the answer. And before I was out the answer, you interrupted me. But go ahead, since you think you know it.
We're talking in the sense of an inverted refraction, right? In that sense, we actually reverse the gradient. You're saying, well, no, it doesn't always invert in the temperature, doesn't always inverse the gradient. Well, no shit. Then you don't have inverted refraction, and you don't have anything to talk about anymore.
Oh, do I need to say it a fourth time? Yes, I do have something to talk about. When you have a temperature inversion, it doesn't mean the density gradient is inverted. It just means things that normally would be changing as far as temperature going down as you go higher, don't go down as you go higher, goes up a little bit and then goes down. But it doesn't change the density gradient that much. to the point where light still bends downward because it's still denser going down, but doesn't bend down as much. I don't know why you can't understand that.
Right, I understand that completely. Right,
well,
I
then you understand that you got a temperature gradient and not have a density inversion.
You are talking about an inverted refraction. That's what you're talking about.
No, I'm not. Again,
that's refracting.
I can't believe I'm.
And you're saying, well, it's not actually inverted refraction. That's what you're saying now. Well, yeah, if you don't flip the gradient, if the temperature isn't extreme enough, if the temperature inversion isn't extreme enough, you're not gonna have a superior mirage. Obviously, well, you don't have inverted refraction.
He switched from temperature inversion.
It doesn't always happen. That's all you're trying to say.
He totally shifted the
I know.
That's so funny.
You're just saying, just because.
No, I'm not saying that. And you're not understanding what a superior mirage is a very complicated phenomena, and it's due to several factors that we're not even going over right now. All we're talking about is looming and sinking refraction, just light bending down, the image not mirroring itself up or internal reflection. All these things are different concepts scientifically. We're talking about something really simple: the density gradient and the light moving through it. Which way does it bend? It bends generally down because density is usually down more as you get closer to the surface. Now, the density gradient can change slightly with a temperature inversion. The temperature inversion will still not alter the direction of the gradient, the density gradient. It'll make it less dramatic, less abrupt. I don't know what the word to use, but it just means the light bends less down. It still bends down, just not as much.
Zanick, since it's so simple, can you look at the two images that I posted and I tagged you in a reply to them from Andrew Thomas Young's paper? Can you look at those two images and can you tell me the difference in the sinking refraction and the standard atmospheric refraction?
I'd be happy to.
Cool. So the -2 Arcman of bending on the standard and the sinking.
When did you do it?
Yeah, because looming is different.
Hold on, I'm not there yet. Let me. Where are you? Where's it at?
Live stream voice spec. So
how long ago did you post it?
2 minutes ago, maybe 3.
Just let me get on the same page before you start rolling off without me.
Yeah.
I don't see any. I think Coco
same
Quad.
page of the same paper from San Diego State University.
Oh, you have an attachment. Is that it? The attachment? Do I get to click on that? Oh, just okay. The graph. Is that what you're looking at? The graph of the.
Yeah, look at those graphs between standard and sinking. What is the difference in not only the image that you're seeing, right, the representation of that triangle with the stripes, but also the arc minutes of bend of refraction? What's the difference between standard and sinking in those images?
I'm looking at it now. Right now, it looks like they're both the same.
Cool.
The refraction. I can't see where that, like the first line, number 2, is it like 6 meters up? That line goes at 6 meters. They both look like 6 meters. Is there anything? Oh no. See how the bottom line? No, they're both -4, -3. -2 is on that line. That's 10 kilometers away. I don't see anything.
Yep.
I don't see anything different between those two graphs. Is there anything different that I'm missing? I got to probably blow it up.
No, because really there's no difference between sinking refraction and standard atmospheric refraction. So in effect, Andrew Thomas Young's reference paper from San Diego State University basically lays out the fact that sinking refraction is effectively what you guys call standard atmospheric refraction, which gives a sinking effect due to refraction.
No, that's not what he said. That's not what he means. That's interesting that these usually his graphs are more dramatic than this. Why would he put these graphs that look the same?
Can we quote you with that interesting, the way that Globers quote Jaron taken out of context in a Netflix documentary when he says interesting? Can we take your interesting and flip that onto you, where when you look at what sinking and standard atmospheric refraction actually are,
it's almost like you copied.
You're like, oh, that's interesting. Sinking is actually standard atmospheric refraction.
Look, you haven't won anything yet. Where is the document this came from? And I would like to look at it because this is not
San Diego State University, Andrew Thomas Young.
I probably have a copy of it anywhere. Did you? It goes right back to that. Okay. The standard atmospheric refraction shows that does it show light bending downward slightly? Yes, it does. It shows that these 2 arc minutes can be. You can actually see it when it should be hidden by. What's 2 arc minutes?
So what does sinking do? How many arc minutes is that bending down? -2?
Depends on the refraction, but generally sinking refraction means something is going to be more hidden below the surface than would normally be seen without refraction.
Than normal? So more so than standard? So why would his images be the same and his representations be the same?
If light bends upward, it sinks more.
There's no mention of that. We see downward. So in standard atmospheric refraction, is light bending upward then?
Standard light is bending downward.
Zanick said, hold on.
Light is bending
Zanick already said
downward.
that if the light it appears to move up, right? If that's not, Zanick's been consistent about that the whole time.
Thank you. Yes, as light bends down to the denser medium,
Wait, down or up? Because Issa said
bends down. Maybe Andrew Thomas Young in this particular picture talks about, I don't know, I gotta go look at this paper because I don't know what he means. Sinking is cut off and his graphs look the same. This is not, it's very unusual. I've seen a lot of his papers and I've read a lot of his papers. I haven't seen this one. I mean, I've seen these chart. I've actually seen this particular chart. I don't remember what it was attached to. Anyway, the point is, if light bends, standard atmospheric refraction will make light bend downward, and that will loom things up that you wouldn't normally see or see at that same angle if there wasn't.
So standard looms up?
Standard refraction looms things up, yes.
Interesting.
No, look at you sound like
So yeah, because based on his paper, looming, you have less of a downward bend. It still is bending downward, but it's just less during looming than standard. But standard and sinking appear as though they're the same.
He might be. Look, we know what sinking we all should know this. If something is lower than it should be, we call that sinking. It's refraction. Now that means the light is bending downward less than it normally would.
So how many arcmen would you expect during looming?
It depends on the distance and depends on the atmospheric conditions.
10 kilometers.
0.02 degrees, approximately about 5 miles.
So it would be, let's say, -1 arcmin. Would that give you looming, or would you expect it to be positive?
What is an arc minute in degrees? 1/60th. Hold on.
Because I can clip the image and post it of looming, right?
Divided by 60.
So if we're looking at
a little more than one, probably close to 2 arc minutes is standard refraction.
Yeah,
for about 5 miles.
And sinking would be the same, and you would expect looming to be less than that, right? Like maybe -1.
No, something that is looming is higher in your field of view. Means the light is bent downward more. If it's higher in your field of view, it's bent downward more. The light's bending downward more. When light bends down, things loom up. Is that a hard concept to grasp? I mean, you agree, right?
So look at what I just posted there.
No. How come I cannot get an answer, yes or no, from anybody when I ask these simple questions?
I'm just trying to reference subject matter experts, not trying to be the citation myself.
No, you're reading something. You're not. I don't think either one of us understand what I don't have any context here. I need to read whatever he's written about it. Between you and me, if light bends
he's written
down,
and he's graphed it out, right?
So if light bends downward, does that mean things will loom up in your field of view? Yes or no?
For looming?
If light bends down, does that mean things will loom up in your field of view, being higher in your field of view than it normally would be? Yes or no?
I mean, light bends down towards the denser medium.
If light bends down towards whatever the reason is, if light bends downward, would that mean things would loom up in your field of view? Mean they'd be higher in your field of view than they normally would be, without atmosphere? Yes or no?
Are you referring to an object or the light emitting off of the reflection of an object?
No, just the object itself. Well, it's reflecting back to you, obviously, because that's how you're seeing it, because the light's reflecting off of it.
Okay, yeah.
Would the object appear higher or lower in your field of view? Or no, I'm giving the answer. Do you agree that the object will be higher in your field of view if light bends downward over a medium, through a medium and over a surface?
It'll be lower.
Well, then we can't really talk anymore until we get that straightened out. That's wrong. It looms up. Everybody knows that.
What looms up?
The argument is that some of these situations that there could be.
Hold on. You can't just say it looms up. What is looming up when light is bending down?
The object means that the object appears to be higher in your field of view.
The lower the light is, the more it bends,
the
higher it
downward, the greater it looks. It's like seeing around a corner. If light bends around, if I'm looking at my kid, I can't see my sink right now. I have a wall in the way. And around that corner, if light was to bend around the corner, if I could make light bend around the corner, I would be able to see my sink. It means it's high, it's in a different angle from where it should be, where you can see it compared to where you can't see it. You're seeing more of an object, for example, or better than that, you're seeing it raise in your field of view higher than it should be than if you didn't have an atmosphere. Looming means things are higher in your. Looming means it's up. It looms up. It don't loom down. It'd be like contradictory in terms. Things loom up, so they're higher in your field of view than they ordinarily would be. Sinking means things are now lower in your field of view. That's caused by light bending upward.
No, it's not bending down as much.
Well, that certainly can cause a slight sinking, but not really compared to no atmosphere.
Light bending.
You have no atmosphere.
The problem is you have light bending. The problem is you have light bending down in both instances. It's the extent to which it's bending down gives you the visual representation of what you're seeing, right? So it's not that light is bending up to give you sinking. It's just not bending down as much as what looming is.
No, because it
Looming
wouldn't sync.
is when things appear extremely high, which is very rare cases. The standard atmospheric refraction makes things appear as though they're sinking more so than when light is bending down further that allows it to loom.
No, that's what you saying it. That's not what the atmospheric
That's
people.
that's
people in
based on the
science or physics
documentation
say.
of experts.
No, the citation says this: that when light bends downward through the atmosphere, things will be higher than they ordinarily would be without the atmosphere. They only
Correct.
sink. They only sink when they go downward, lower than they should be without an atmosphere. It's all based on no atmosphere. That's the relative. That's the relative 0 point.
We have no
just because something is less. Hold on. This is the answer to your question or your statement. It addresses that statement by saying if the atmospheric temperature inversion, for example, is happening, there's less looming. Doesn't mean it's sinking. You could say one image looks like it's sinking versus another image that was taken yesterday, but that's really incorrect. It's still loomed. This is not loomed as much. That's a more accurate way of explaining it.
Yeah, well, looming and sinking are both atmospheric effects. Standard atmospheric refraction is more closely related to a visual representation of what sinking refraction is. And sinking refraction is just light not bending down as much as it does when looming takes place.
It says you're saying that. That's not how I understand it.
That's what Andrew Thomas Young says.
Well, let me pull out the paper so we can go over it and I can probably give you some enlightenment of that.
Cool. You can look at the images that I posted.
I have the paper. It's saved.
I posted images from his paper for all three of these instances.
Well, you got to read what he says about them. Refraction.
You give me the citation from him that refers to sinking refraction as light bending upwards.
All right, I got his whole paper here in front of me.
Cool. So point me to where it says upward bending light or sinking refraction.
Oh, okay. you know what, you did exactly what I thought you did. It copied some things out of place and position. The one you have posted, which has the 2 arc minutes, that is the whole thing talking about looming. And then it talks about sinking, where it has the 1 arc minute for the 10 kilometers.
I'd have fun.
The part you didn't have in your drawing is the part I put in there. The sinking had the 2 arc minutes in an angle.
Oh, standard.
Hold on. Listen, the sinking had the 2 arc minutes at the bottom of that little miniature graph to the left. That you didn't.
What does standard have?
Oh, God dang, stop talking.
I'm talking about standard.
Stop talking for a second. Let me finish the sentence. In the looming, it has 2 minutes on the x-axis, on the y-axis, and 1 minute in the x-axis.
I'm not disagreeing with that.
So it's a different slope of that line. The lapse rate is different.
Nobody's talking about looming.
His point is, he talks about things you see of the object over the curve. The sinking versus the not sinking. It's very, very subtle.
So
it's a totally different graph than you have. The looming has a negative 1 minute.
Keep talking about looming. Everybody knows we're talking about standard and sinking, but you want to bring in looming to make your point. When my point is standard and sinking are effectively the same.
Offset the density of the water because it would normally be denser than air.
You can't ever make air denser than water if you right. You can't. That's why you have it. Just like you have glass in air or glass in water. The glass is denser than the water. That's why it bends through the water. That's why it bends through the glass and bends in the direction that is the acute angle to vertical. Based on that's the most dramatic effect of refraction you're going to get because it's such a great density variable. But just like this example I mentioned in the beginning, even if you have glass in water, you shine it directly through it, where it's at a right, it's straight through it, where the angle is right through the glass, right through the water, no angle of incidence. Then it's not going to refract because the angle is not positive or negative, 0. So it's got the angle of incidence and the ratio of these two densities.
Yeah, I'm willing to say I'm not asking good questions, but I appreciate it. And I'll listen back to it for sure.
Those are good questions. Those are really good questions, actually.
Okay, thanks.
So Zanick, instead of solving like all the cosmological problems of the world, do you want to solve all the political ones?
Yeah, I'm more afraid about that these days than anything else. Jeez.
Yo, did you see Epstein? Yo, you ever seen the like Dan Pena? You know who that guy is?
Who?
Dan Pena, I think, or whatever like that. And he's like, his quotes going around. I remember seeing it years ago, but anyway, he like talks about how the founder of Bitcoin, if anyone knew who the founder was, they'd want to sell it as big as they could. And then it comes to find out, and these Epstein drops, like Epstein's talking about Bitcoin in like 2010, and like fucking.
What was Epstein? I don't remember that. What was he saying about it?
There's some kind of. He says in one of the emails. He says I forget who he's going to talk to, but he's like, yeah, I'm going to tell them about Bitcoin, and this was like I think 2000. I forget what year. Well, I really just heard this recently. I was hoping maybe some of you guys. I don't really have the time to fucking spend too much time on all this shit, but I guess he's like was talking about Bitcoin before it was a thing, and like the theory goes like, what if fucking Epstein like made Bitcoin because he was a fucking financial genius, you know?
Yeah, right.
So they say.
Well, he had an island. He had a lot of money, and a lot of
Dude, what do you think too about the conspiracy that the Island Boys are his kids? And there's like a picture of him with these two
Can you
kids.
imagine? I mean, that's pretty funny. All these young girls, 18, 17-year-old
Dude, and then, dude, I guess he was hanging out with Mom Donnie's
Oh, I saw that one today.
mom or some shit. And
Yeah,
but I don't know.
well,
There's just some AI pics and shit. It's kind of fun.
is that real? No, it can't be real.
I don't know what exactly is real versus what is.
So Mondami is actually his love child.
That's like one of the like test tube, or even worse, like test tube babies and shit. Because dude, they were talking about like
right.
Yo, did you see like the whole fucking thing where he talks about like the transgenderism and getting kids to like be trans? Like it's this it's a back and forth with one of these like evolutionary biologist guys, and they're talking about how to make people like be gay, basically, and like the effects of it. And the one guy's like, even like, I wouldn't do it to my kid, and he's like, but we could try it out with these people, and fucking, it's fucking wild, dude.
Mm-hmm.
It's pretty wild. You not paying attention to any of the Epstein shit? Nobody in here pays attention to anything but fucking like air pressure and shit.
No, I'm watching this stuff every day, and all the fucking things coming, all the memes and all the YouTubes and
it's so
Instagrams
funny.
and all. I've seen them all. I mean, I love the way they're the double standards and why they are. Trump, he's buddies with this guy, and they're best friends because they're in a picture together. Really? Is that,
dude, it's so funny.
There's a top UCLA neurology professor who's writing to him about you can get newborns to suck harder by playing sounds of their mother's voice.
What?
Did you not see that? That's the latest today.
Holy shit! No, I haven't. Like I said,
everybody's trying to get this guy fucking. They're saying that the UCLA board needs to immediately remove this. He's been there like 20 years at UCLA.
Wow.
What's the context of that though? Like sucking their thumbs?
No, dude, like talking
pacifiers?
about being gross, dude. Like the whole Pizzagate fucking shit, dude.
Oh goodness.
I mean, he's going to say, we were just talking about the interesting mind of a newborn because I'm a neurologist, and as a neurology professor, it's interesting to know what the human mind can do.
Oh, dude, it's so. Hey, Jake, can you pull up, or would you be savvy to what it was said about Bitcoin? I know Epstein.
Well, he invested in some Bitcoin thing in like 2014 when it was like $300, whatever it was in 2014.
Can you imagine?
Right. Have you heard these theories? Like, there's like a theory he's like possibly behind the creation of it.
I was going to say too that the term flat Earth could imply just a stationary planar, Earth surface as the ancient cosmology and really the largest, most foundational cosmology in all of humanity, as far as we know, outside of this kind of globe concept and the whole roots of wherever this globe idea came from. But I mean, every other cosmology that we know in all of time has a planar stationary Earth. So the term flat Earth could imply two things in this context that I'm going to say right now. It could imply more, but one of them is just an Earth that has like a foundational planar geometry and is also stationary, as the ancients and all of humanity since the dawn of time has always had. And then the other one is the term flat Earth kind of linked to that Gleason's azimuthal equidistant map and the sun path that is claimed on that map, and the Antarctica as an ice ring, and the no 24-hour sun that kind of goes with that little package, and really no explanation for the southern stars, I would say. But anyway, all the other factors. So when people say flat Earth, like the way you were saying at IC Spin, you're kind of implying that flat Earth made a prediction. Well, maybe the Gleason's map concept or that model had some relation to that, but not necessarily just the Earth being stationary and planar. And in the entire field of people who, in terms of flat Earth, as it were, to use that term, it's not all like a Gleason's, that little package of the Gleason's thing. Some people don't have a model. Some people are open to other layouts other than the Gleason's one. There's just a wide range of perspectives that go with that. So I just think people link that in together as if that's the only way the Earth can be planar and stationary is just that Gleason's map, and then trying to link, that people got stirred up on that map or into that or whatever. But that's not the case for everybody. It's not like everybody that has a stationary planar Earth, is necessarily linked to that Gleason's thing and the no 24-hour sun claim. I mean, there's a percentage of people that may have leaped onto that, but there's a lot of people that were just either neutral on it or were like, hey, there's not a lot of good evidence for the sun there, but they were just kind of on the fence about it or made comments about it, but were not hinging their entire view on just what the sun did there.
Is it fair to say, Gio, that I don't know this about you, but is the Gleason map dead for you?
It's not about it being dead or alive. I never asserted dude, I haven't mapped the entire Earth. So to be intellectually honest, why would I jump onto some other map or model? You know what I mean? People jump onto the Globe thing, they jumped onto the AE map. And I even think about people that jumped onto the AE map. It's why? Did they check it? Did they map it? Did they check the distances in the south? Did they check the ice, that Antarctica was an ice ring? Did they check that there's no South Pole? No, they didn't do any of that. They just jumped on it like a baseball team, their favorite football team. Were yeah, now this is my thing. Now, some people were more neutral on it. But for me, yeah, of course, we've talked about it over the years. It's been one that's presented. There is some historical, with that type of a layout of the coming out from the north, meaning there are some maps like the Yerba Monte map from the 1500s. We've all dug through the internet and found some of the maps from even the 1920s, but also the 1800s, 1700s. So there are some of those maps. Now, whether those are actually from those time or planted, who knows? It's a whole other story. But I'm just saying that was a proposed kind of layout. But I guess to answer your question, for me, I never claimed that that was the Earth or whatever. I never, like, maybe Jaren did do that. Maybe he was like, this is it, and he put it on his, and really pushed it to his people or whatever. So maybe he does have, some kind of karmic repercussions for that, if or whatever it is. But I mean, for me, it was never really dead or alive. It was always just something that was like presented. It was something that was there that we talked about, and about the idea of that type of a layout. But however, I mean, it's always been problematic for me. Like, the southern stars don't match at all on that layout. Also, the sun going straight on the equator, the sun and stars that rise directly east and set west, that doesn't match with a circling sun on the equator. The distance from the claimed on that Gleason's map from the equator to the North Pole doesn't match the distances as well. So there's a bunch of factors about that map. Also, the greater distances in the south. So there's a bunch of things that I've always thought are problematic. Lastly, like the sun rising south of east and setting south of west, meaning the sun arcs the other way when it goes south of the equator. It doesn't keep making concentric circles. So, I mean, these are issues that I've been aware of for all these years. And that's why, to me, it was just sort of an outstanding question of, okay, what is the exact map and what is the true layout? If we've been lied to, it would not make sense that those of us aware of this are just going to instantly have the whole thing. So, yeah, so I guess to me, to answer your question, it's not really about it being dead or alive. I mean, I think it's always had a lack of viability with the sky. And to me, them going on that TFE trip, it was not really that much more in addition. I mean, in terms of the evidence of the sun there, it was like a little extra piece, but I mean, there's at least 20 or 25 other footages of the 24-hour sun there. There's a bunch of footage from Union Glacier that I found. I even found a 24-hour sun footage from Union Glacier before they even went on the trip. So, I mean, to me, them going like, yeah, it was cool to see those guys there and live streaming, and like, yeah, it gave a little bit more, kind of directness to it. But to me, I'm just saying it's not about like some kind of huge shift. Yeah, go ahead.
Geo, can it be a globe?
Can it be? Meaning, is it possible? And what do you mean?
Is your position as a flat earther falsifiable in the sense that it could be a globe?
Well, I don't really refer to myself as a flat earther, but that's kind of a separate thing. But that's fine. I mean, if you want to call me that, it's but I'm just saying I don't really.
I got you.
What are you asking? Like my percentage of what I?
No. Just like, could it be a globe?
What do you mean? Could it be like could whatever, let's say whatever is behind the intelligence of creation of this realm, like I'm not trying to go a whole God thing, but like, are you saying could that force of energy that is behind manifesting matter and consciousness and everything, could that in theory make a globe Earth? Is that what you're asking?
No,
or are you saying, do I think it's possible that, are you asking me, do I think it's possible it's a globe?
Yeah.
Is that what you're asking?
That one. Yep.
Yeah, so that's what I was saying. Are you asking like a percentage of what I, some people say, oh, they're 99.9% sure of XYZ. Is that kind of, that's what I was saying.
I don't need a percentage. I just want to know, is it possible from Geo's perspective that we live on a globe?
Well, I mean, I think in terms of my own intellectual honesty, I'm a limited person that has not like mapped, modeled, measured the entire Earth. So, I mean, I can't say that I have like 100% absolute knowledge of what the entire realm is. If I were just to say a simple comment, I would say from like that I suppose I would say a very, 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 very small chance, if that's what you're asking, like a very, very, very small chance. But I'm just saying I don't have like, dude, I think we need to do more things. Like as a community, we need to actually do more measurements. We need to measure water tangibly, physically. So there's certain things that need to be done, like in order to like flip the entire paradigm. I mean, for me, like on my own, in my own journey of this, like I just like this would go more on a spiritual level. But I mean, I have my own being tuned into like what this creation is, essentially what this realm is, and I don't think it's a globe. But at the same time, I can't say that I've
let him finish.
At the same time, I can't say that I've tangibly, physically measured, a lot of these factors, like water curving. Obviously, I haven't been to like extremely high altitudes, and so I mean, just being intellectually honest, I can't say that I'm like. I mean, dude, with $100 million in a decade and a research team, then we could all be and 100% solidity at some point with $100 million in a research team and a decade. But yeah,
100 billion or more.
I think flat Earth supremacist was had something to say. I wanted
to say we need objective measurements, we need objective evidence, etc., etc. That's it.
Well, can I flip it back to you? What is your percentage that it's planar and stationary? Icy spin. Could it be flat, as it were, to you?
It could be flat. Sure.
Okay. What is your? I mean, like 5%, 1%, fraction of a percent. If you, I mean, what? Like,
I would probably lean the way that you, like the language that you used when you described your percentage. That's my feeling. So like somewhere in the 0 to 1% is kind of what I got from what you said, right? Like very, very small.
I think these are the intellectually honest positions because we like. Okay, like we were all just born, we popped out of our mother, we're in a hospital, and then we went to school where we were brought up in some, region of the world, and then we're here. And I know that like certain Globe folks claim like this evidence or that evidence or, earthquake data and so on. But I mean, even like someone like, just to mention like PhD Tony, who's like he's a PhD, he works in geophysics, or like he actually works in that field. He's a PhD. And I mean, even he, and I'm not trying to like call him out or anything, but even he has said like it could be flat kind of thing. So I mean, I think it's intellectually honest unless somebody has, basically a research team with millions of dollars that can independently actually do all of the things that would be needed to really have something absolutely definitive. So I think it's intellectually honest. Now, if people want to come from a spiritual perspective, like if you ask me on a spiritual level, I would say the chance it's a globe is 0. But if you're asking me more on like the, kind of tangible, physical, what can I prove, that level was more the level I was, responding to in terms of.
Yeah, that's fair. Who was it? Someone else, not Flutter Supremacist, had something to say. Was it?
I'll step back. It was a good kind of question. Yeah, with the 24-hour sun thing, and I know I kind of.
No, it's okay. Did you have anything
here,
else? Did you have anything else to say? Did he leave? Who was it I was engaging with? Issa. Did you have anything else to say? Yeah. Or Andrew was there. Andrew came in and interrupted Issa. I thought was fine, but Issa sort of got pushed to the back row.
I did not interrupt anyone.
No, I know. I think you did. I think you came in at the right time. But okay, Andrew, did you have anything else to kind of assert?
Not unless I was going to go on to a bit of a monologue. So for the time being, I'm sitting back patiently and listening.
Thank you. Can I ask Issa, did you have anything else further when I kind of our back and forth? Is there anything you wanted to get out for me to consider?
I was curious, what are your thoughts on a geocentric Earth? Like, even if it were a globe?
A geocentric stationary globe?
Yeah, because I think, like, the argument for the globe, in my mind anyway, if I were to, or I don't know, like, it's like the idea that you would just, I really think that if the Globers just gave up Bill Nye's #2 hit list, boats going over the curve of the Earth and any kind of, like, optical, any of that, that the globe would be much more suitable in my mind, I think. Somehow. But I think like, and if it were like a geostationary globe that everyone admitted you'd never experience any curvature, but the Earth is a globe based on our understanding of the celestial sphere, etc. And if that were the case, what would you think about that versus the current model of today?
It's a good question. I think with the retrograde motion arguments that I've heard and the cosmic ladder video by Terrence Tao, the 2-part series, have convinced me that people know more than I do about it, and I defer to them.
Right, but aren't those like just observations, right?
I guess, yeah. I mean, if they're out in the universe, right? To some extent, yeah. I mean, if we're talking about beyond further than I think that we could go, or we have been purported to go, yeah, sure.
I think a geocentric stationary globe, to me, like it definitely is. I mean, dude, just the motion. Like I was actually just thinking like an hour ago. I was just like, dude, just like look around. Like the idea that your whole house, your whole world is moving at millions of miles an hour, inverting every 12 hours. You're upside down from where you're at 12 hours from now. You go to bed, and when you wake up, you've moved like 500,000 miles through space. It is so like intense and wild to think of that factor. So I'm just saying, like,
dude, you know what else is weird, Gio?
Well, let me finish. I'm just saying a stationary globe at least has like the grounded, visceral. I know there's the beliefs of you're moving and you're spinning and you can't feel it. I know all the arguments. I'm just saying, and Issa talks about this too. It is such a massive leap to think that physically, spatially, that's actually happening. So I'm just saying a geocentric globe kind of at least grounds that somewhat.
Dude, you know what else is crazy, Gio? This crazy idea that you're sitting in this chair, comfortable, sipping on your champagne when you're 8 miles high, and you're traveling, a mile every 2 seconds.
Why is that?
And you're 8 miles high, way higher than anything can live or breathe, and you're just enjoying your gourmet meal and your steak and your champagne, sitting in your chair. You can barely tell that you're moving, but you're going like, you're going like a mile every 2 seconds. Like that's so weird, isn't it?
No, I mean, I don't find that comparable, because you can get in a car and you can go 100 miles an hour. So being in an airplane going 500, 600 at a high altitude, airplanes fly. We know airplanes fly. You can make a paper airplane. You can have a radio control airplane. That's not a big leap that you can.
Yeah, but when you're sipping, even though you're going like 12 times faster than you've ever been in a car, you feel like you're moving way less than you are when you're doing 100 miles an hour in a car, right?
Oh, say it again. Sorry, if that was.
And when you're flying in smooth air like that, it could feel like you're just sitting on the tarmac, not going 12 times faster than you've ever gone in a car, compared to what a car feels like, at 100
Right,
miles
but
an hour.
it doesn't make the case for a moving Earth. That's the thing.
I mean, it just goes to show that depending on this whole idea that we're just like, how could we be going so fast and turning around? It's all based on what you're experiencing, right?
Wait.
Well, hold on
Issa,
then,
do you
hold
think
on.
it could be a geocentric globe Earth? Is that why you asked me that question?
I'm cosmologically fluid, but at the same time, obviously, if that's the case, then Jake, then our cup of tea microcosm in regards to what the ocean is makes more sense. Because you're going to say if you're flying, well, because the horizon's so distant, you can't experience that you're moving 500 miles an hour because there's no reference, right? But the idea is that then that confirms our microcosm, and that's I think the airplane, the tennis balls, the fucking all that about relativity doesn't it's not convincing enough. You know what I mean? Whereas the analogy of a cup of tea being the ocean makes way more sense. You know what I mean?
Go ahead, Jake.
I mean, Jake, it's also, that's in one direction. Like if you're in a, it doesn't, because everything has been brought up to that speed, like 500 miles an hour. But the globe Earth, it's millions of miles an hour. It's in multiple directions. You're on a ball. You're spinning on the axis. You're going around the sun. The whole solar system is going around the great attractor, etc. It's a lot more motion than just going straight in a vehicle, in a train or a plane. It's not the same, being on the outside of a ball.
It's literally it's a globe because what do you call it? There are no symptoms. You know what I mean?
Well, I make
one
a
of the
joke about
symptoms
this.
is the symptoms. It's that's what this is like with the globe.
Well, dude, I make a joke sometimes. Let's say someone's lying on the couch and you walk up to them and you're like, hey, bro, so right now, okay, there's this thing called roller coaster force and you're in roller coaster force right now. So actually you're turning and tumbling and spinning all over the place, but you can't feel it. The symptoms of roller coaster force is that you can't feel it. You can't detect it. You don't know you're under roller coaster force, but it's happening. Trust me. Yeah. I've made that kind of joke before.
Yeah, dude. And no. And we need some tax dollars to work it out a little bit better. It's Barnum and Bailey. It's my the whole space program. I swear to God, it's Robert Anton Wilson and a bunch of fucking psychonauts got together and thought, how can we fleece the government? And they were fucking moon landing. They went with it all the way up to CGI. Fucking, it's the greatest hustle in the world.
And they're still doing it.
I know, and I almost don't want to fuck it up for them. You know what I mean? That's how I feel. I'm good for you. You got the government to give you $19 billion so you could fucking make some CGI images. It took you 15 minutes.
Yeah, but unfortunately, I think it's darker than that though, because I don't think these guys need the money. They print the money. They might want us to have less of it.
No. What I'm saying is that the psychonauts, the friends of Robert Anton Wilson, snuck in, and you know what I mean? It's the merry pranksters, getting a government division, and they I can't believe we got a fucking corner office. I just feel it's a bunch of pranksters trick the government to get $19 billion a year.
Issa, could it be a globe, a heliocentric globe, from your perspective? I know that Geo said that a very, 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 very small percent. Do you agree?
It's all possible. I mean, I grew up with the fucking, I grew up with Pluto, man. When we had Pluto and shit. But I just think I'm I understand those models and there's a possibility that those are what it is. I just think that also the thing about flat Earth really is just about accepting. You're kind of granting your own senses and own experience some validity. Where I think the globe, as beautiful of a model as it is, it kind of diminishes one's almost respect for one's own position. And this is a psychotic relationship because it's potentially gaslighting you with these concepts, like I said, where the symptoms are one of the symptoms is you don't have any symptoms. It's I just think that there's a lot of that going on. And I just think the relationship and the ask of the globe philosophically is almost not worth the price of believing in it, to be honest. There's a lot of baggage I think that intellectually comes with it versus the alternative, which is the idea that you could trust what you see and what you perceive in this world, as crazy as it may be. But either side is ridiculous at some point. You're floating around the sun, going through space, Halley's Comet fucking showing up every 70 years. I just think it's both sides are ridiculous.
So to summarize, it could be a globe, yes?
Sure.
Okay. Well, do you have any evidence that it's flat?
I think, yeah, you go to the ocean. You know what I mean? You can, I think experiments left to right, it looks pretty level. I think if you go up in a tall building and you look out at the same ocean, it's still level.
Does the horizon always rise to eye level?
I don't know if I agree with that line in particular. because it's kind of become a trope, you know.
Yeah,
But I think,
I agree.
I think like atmospheric shit happens where
What
people
about
are
on a
still
clear
like,
day?
well, I think you're still dealing with heat, or you're just dealing with a medium. It's like the Weather Channel. The Weather Channel tells you how far you can see.
Have you ever seen this image here?
Oh, I don't know. So late, I gotta go to bed. I'm thinking, man.
Yeah, I get you, man. If you
What is
wanna,
it? Let me see. I don't know if I've seen that one.
okay, I can elaborate. This
Is this
image
the
was
one
taken
where?
in.
Is this the one where you
Yeah.
ask me if there's a straight line?
They compress
No,
it. Yeah, you can compress it and it makes it look curved.
Well, no. Is that what this is? Because I've been through
may I?
this before. I've been through
Yeah,
all this shit, bro. I've seen it all pretty much.
okay. May I go through my 40-second spiel with this for the audience?
Yes, sir.
So this was taken in Ibiza, and I've got all of the coordinates and the person that took it. Known straight edges are on the left side and the right side, balanced on this green table in the background. And as you can see, if you zoom in on this particular photo, you can notice that the horizon is split evenly to a degree. It's all encompassed within the two metal bars on either side of the table. You can gather the horizon there. When we squeeze or compress it, as Gio said, when we squeeze this photo to further accentuate what's curved and what's straight in the image, we get something like this. And we're looking at the